Okay, welcome back. We hope you enjoyed your lunch. We're going to kick off straight away with the afternoon session. I would also like to say hello to our online viewers and participants. Hello. Let's all give them a wave. Everyone a wave, please. Very nice. Okay, thank you very much. So, moving swiftly on, we have the session ESCAPE VO, a European Virtual Observatory, and your chair will be Mark Allen. And Mark, I don't have my glasses on. No, it's too late. Mark looks after Work Package 4 of ESCAPE, connecting ESFRI project to EOSC through the Virtual Observatory Framework, and you're the director of the Strasbourg Astronomical Data Center. So without further ado, over to you, Mark. Thank you
very much. Thank you very much. I think I just jumped straight into it, thanking everybody in the ESCAPE project, in particular Work Package 4, who's been working very hard over the last years, really bringing together people who may not have been working together otherwise, and I think that's one of the things of the ESCAPE project that comes out, you know, that human connection, even if it was online, to work together. So I'm joined today by Francois Bonnerel, who's been looking after one of the tasks in Work Package 4, and 4 panelists who represent various of the ESFRI involved in ESCAPE. I'm just going to jump right into the presentation, make sure we have some time for questions at the end, and present the work as we go along. So, what is the Virtual Observatory? It's quite clear, I think, to many of the astronomers in the room, but some of the others may not really know. It's a system, it's a framework where we enable the fair sharing of data using common standards and bringing along the data providers who can publish their data in a standardized way, connected with the publications, and then enabling tools like the ones you see here to use that framework. So this is the way we present it, for example, to the students and postdocs and early career researchers who come along to the training events. And you have tools like this, for example, where the data is built from a registry, a bit like a catalogue in the EOSC. There are data from many observatories and missions. There are thousands of all-sky data sets. They're some of the largest catalogues, and you can do complex queries on them. And you can access them also through APIs and, for example, in the notebooks shown as the example there. So that is a kind of virtual research environment of interoperable tools built on standards in which we really think and want to be involved in the European Open Science Cloud. So here are some of the key words about what we've pursued in the work package about making data fair, findable, accessible, interoperable, reusable, using the Virtual Observatory, which is an operational framework. You can really publish to the VO today, use VO tools today. It's been a kind of pioneer for data sharing in astronomy. There's a global network of people who participate in that. And there's an organization called the International Virtual Observatory Alliance, where we go. It's not a separate organization, it's where we go to participate in deciding on the standards for the domain of astronomy for the data to be interoperable. And that makes it really interesting as part of EOSC. It's recognized in the ESFRI roadmap. It's part of the EOSC Strategic Research and Innovation Agenda, the SRIA, and it's linked into our AstroNet and networking activities as a framework. The approach that we've taken in ESCAPE is to bring together the astronomy ESFRIs, their research infrastructures and their associated partners, together with partners who bring in expertise about the virtual observatory, about data sharing, about the standards. And we've fostered cooperation between those to work together that has gone beyond ESCAPE. We, for example, have lots of participation in the events and in the work from other institutes. For example, there are people in the room today from the EuroPlanet consortium, and they have helped enormously throughout this work. So this is the approach of bringing together these partners in ESCAPE. So the approach has been, one, to try and integrate the virtual observatory with the EOSC at an early stage. The biggest work, which Francois is very much involved in, is the implementation of the FAIR principles through the virtual observatory. So that is, you know, representing the ESCAPE priorities at the international level and making standards that you can really implement and use to make the data interoperable. And there's been other activities about adding value, and something that comes from ESCAPE. If it was just working on the virtual observatory itself, you wouldn't have this. Working in ESCAPE, you have that cross-work package interaction, for example, about VO services available in the platform, about the VO software onboarded to the open source software repository, and we've explored even how this interacts with the data lake, and it's supported for use, for example, in test science projects. And so what actually happened, here we are at the end of the project. We do have a deep analysis reports on that onboarding into EOSC through EUDAT. We've had a whole bunch of standards approved, as well as 2 science schools and forums for the data providers to come and understand, really with hands-on activities, how you really implement those standards. This is my summary table of how we've linked with all of the ESFRIs and research infrastructures in the work package, with results in terms of the standards that are interesting to them. For example, radio astronomy was not very much integrated into the virtual observatory at the beginning of the project, whereas now we've stimulated the creation of an astronomy interest group, radio astronomy interest group at the IVOA level, which is bringing all sorts of benefits that will lead into for ALMA, for SKA, for the future. We've also built heavily on the needs of CTA and CAIM3net, for example, for data provenance standards, as well as covering the whole gamut there from optical, gravitational waves, solar physics. So just to give you a couple of really concrete examples of things that will last forever because we put that effort into ESCAPE, is the standardization, for example, of the provenance data model. What happened to your data along the way from getting from the telescope to the archive? There's a standard about that. There are papers. There's a whole framework of how to build a management system around that. There's another standard which I'll highlight, which is called the multi-order coverage map, which is a complex way of dealing with regions on the sky that enables you to do things that are very difficult in databases, but allow you to manipulate those regions on the sky, and you'll see a nice little movie at the end of this presentation showing the sorts of things that's enabled. But they're concrete, approved IVOA standards, published and being implemented in projects that are way beyond just the IVOA, just the ESCAPE project. You'll see some nice pictures about gravitational waves. In terms of having those VO resources in the EOSC, there's a first step that's been made into B2Find, so that you can find, if you onboard the whole VO to EOSC, then you get tens of thousands of resources available, and this is our goal, to have that first level of metadata interoperability demonstrated by having eventually EUDAT in the EOSC portal. And here I come to the end, where I want to show this nice little video of some work about using the all-sky data that is produced by ESFRI and the different research infrastructures in astronomy that's feeding into the SKA Science Regional Centre prototyping, where this is not just a movie, this is actual access to real, well, it's a movie of accessing real data. And the more you zoom in, the higher resolution data you find. This is the example of the SKA Pathfinder Meerkat in South Africa, of real data. And this representation shows that we have access to that multi-resolution data in a way that is not just for visualization, in a way that's really scientific, the way that you can deal with the FITS version of that hierarchical structure and generate accessible data in systems like this. Today we're going to hear from, you don't need to just believe it from me, but really the infrastructures that were involved in Work Package 4 are going to present their work. So Martino from ESO and Mark from Jive, Giuseppe from IFN Perugia with the Ego Virgo, and Veronique from here in Belgium, Royal Observatory of Belgium, on the impact of the VO force for solar astronomy. So with that, I'll hand directly over to Martino, who is first on the list.
Which one is this? The big one.
The big green one.
We've established that, it's the big one. Okay, so a couple of minutes on what we at ESO do with the VO, and we've done through ESCAPE. So first of all, who are we in the first place? We are an astronomical observatory, okay? So what we do is that we observe the sky, and we do that not from Germany, where the headquarters are, but from Chile, because of course you need to have, you don't want clouds that characterize the sky in Munich. We go to Chile to do that, and we have 3 sites, well, many sites there, and you see there on the left-hand side a summary of those. We are an there's many governments supporting us, and we were founded 60 years ago this year, so happy birthday to us. We have 16 member states by now. The host state is Chile, as I said, and we have a strategic partnership with Australia that hopefully will lead someday to a full membership. So this is what we do, and we basically develop telescopes and observatories that go beyond what the individual member states do. Okay, so that's the important thing. And we want to provide our community to access to high quality science data. The fact that we do that is deeply ingrained. You don't need to read all of the text. This is the Science Operations Policies, which is for us, which is a council document. That's the highest governing body, it's the ruling body of ESOS. It is very, very high in the thinking at ESOS that at the end of the day, we observe to make the data available to people in a way that they can be used scientifically. Okay, so just collecting data, it's using the data. And ESOS supports an open data policy. Okay, so this, I think, is a bottom line for this. Why do we do that? Because it works, because it fosters science. This is a graph with time on the x-axis of the fraction of papers that use ESO data coming from the archive. So these are not the people who have proposed originally for the data. These are people who reuse the data for their own science. And you see it went from essentially 0 when we started 25 years ago or so, and we are almost at half. We're at 40% now. Okay? And this growth really shows the power of opening the data in a way that people can use scientifically. So that's why we do it, and that's the result. Beyond that, the impact of the ESO archive is wide, and again, it's because it is a science resource. You can go back to the data and challenge any result that somebody has claimed. It really fosters cooperation. You have a source of data and bringing people together to the data. And it broadens ESO's community. I mean, you can read all the details later, but it's important to notice that, first of all, the community is large, and then a third of the people who use the archive wouldn't interact with ESO otherwise. So it's really a way to broaden ESO community beyond the traditional model of going to the telescope and getting your data. And then it reaches beyond ESO member states. That's also important in the sense that the ESO archive is open to everybody, even to those who do not pay the bill at the end of each month. And that's very, very important in terms of open science. Virtual observatory. The observation is that 50% of the ESO science results do not only come from using ESO data. Really, science thrives from bringing different data sources together. It's not, again, the old paradigm anymore. You have your data set and you do your science. It's not that. So if we want to foster this, we need to make data speak to each other, and we need to make people speak to each other. And this is where the VO is absolutely fundamental in doing this. And we've seen it on the ground. And it's so for ESO itself and for coordinating beyond ESO at the European level and at the global level. Really, 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 the action happens. So this was really a fundamental thing. I don't want to read you, I don't want you to read any of this. This is just a partial list of the VO protocols that we use in the ESO Science Archive. So the bottom line here is that it's a long list. Okay, the details don't matter, it's a long list, and it's deeply embedded into the workings of the ESO archive. The ESO archive would not work without VO, and it would not work without the developments that ESCAPE has brought to VO throughout this year, because data evolve, and VO needs to evolve with it. These are just 3 examples of interoperability. To the left, yes. ESO plus LIGO Virgo, so this is the contours of some gravitational event. This is the neutron-star merger, and you can see you plug it into the ESO archive, and you see the ESO assets, the ESO data assets there. Same thing, bringing together the optical and the ALMA side, so the millimeter side of ESO that's on the right. And the one at the center is not an ESO product at all. This is ESA-SCAI, okay? This is the ESA portal to the data, which talks to the ESO archive behind the scenes through your protocols, and you see again the results there. Data coming together to do science. In summary, the virtual observatory is central to the success of the Science ESO archive. Success of the ESO archive as measured, as I said at the beginning, by the science output that it generates. CIVO, specifically, provided crucial support to the ESO Science Archive by developing the tools, the protocols, and the standards that need to evolve as the data and the needs evolve. It has coordinated the involvement and expansion of the astronomical community. It's connected, of course, it's connecting to the EOSC, which is the European playground for all of this, and it's very important that we are connected there. And it's also, CIVO provided training, because we need to bring people together. And this is what the training is for, and this is why it's so crucial to have that. A slide about the future. The VO is mature, but this doesn't mean that it can stop here. Data evolve, like I said, necessities evolve, the VO needs to evolve with them. It is an essential component of this ESO archive, I said. I don't know of any major archive who does not make a heavy use of the VO, it needs to evolve, like I said, and the ESCAPE Open Collaboration Agreement is in an ideal position to make sure that this continues successfully in the future as it has in the past. And this is where I would like to leave you. Thank you very much.
Thanks very much, Martina. Let's go straight to Veronique. Whoops. Here you go. So it's just this great big green button up in there.
Okay, so I'm from the Royal Observatory of Belgium, and I will present you what impact ESCAPE had on the solar physics in terms of virtual observatory. There were two main people involved in the European Solar Telescope that was involved in this work package. So this is the Royal Observatory of Belgium and the KISS Institute in Germany. So the goal of our task was to enable high-level data products and archive service to be interoperable in the VO framework, so that they can later on connect to the EOSC. Through the VO, you know all about this. FAIR principle. Every element, of course, here is important to find, to access, to be interoperable with many different tools, and to be reusable. So what was there before ESCAPE? We had built within the SolarNet European project a type of a VO VO tools, the SolarNet VO, which basically allows you to find, to get the data. The point is there was no standard involved, or hardly none, and the idea was to put as little constraint as possible on the data provider to provide their data. We are using FITS file a lot in solar physics, so this was limited to FITS file. As I said, there was no standardization, but within the SolarNet project, there had been some recommendation to FITS keyword enforced. And with this recommendation, of course, the work of including the dataset into the VO was much easier. So what we then did is to go further, and the first thing we realized to do was to elaborate a bit on this metadata standardization. We were looking to see if there was a need for an extension to solar physics of the Europlanet table access protocol. And so we look at actually the correspondence between the EPN core parameters and the SolarNet fits keywords. And actually there was quite a good correspondence between them, so that was already a first step. We also reviewed the unified content descriptor for the needs of solar physics. We compare with other databases that existed in the field, and we proposed some addition of UCD. So that was for the metadata. Now for the data access layer, we implemented some TAP services at the Royal Observatory of Belgium. So we also are the World Data Center for sunspot number. And so we have a very long collection of sunspot drawing, and that was put into a TAP service along with the corresponding sunspot group catalog. We are also a space weather operational center, and so when we get oops, sorry. If I want to go back. No, okay. So we had a second services concerning the coronal hole data sets. So as I said, we are an operational services, and so on solar image, we have algorithm to detect coronal hole, active region, filament, flares, etc. And the properties of this feature, we input them into an EPN tab. But we want more. We want the SolarNet VO to also be interoperable with other things, not on, and to, in particular, be a TAP client. So we included into the SolarNet VO two other TAP services from MEDOC in Orsay, the institute in Orsay. They had made an EIT synoptic maps and differential emission measure maps that they had put into a TAP service, and with the standardization of this protocol, it was direct to include that in SolarNet. And then further on, we have a visualization tool, which is called the GLO Viewer browser, which can be used to visualize images, timelines, and events. And we wanted this Helio Viewer to be also interoperable with different things. So again, with using the standard, it's very easy to get from a TAP service that is out there, for example, the ESA archive TAP, through the SAMP protocol, you can immediately visualize the images into GLO Viewer. From the SolarNet view, because you have this recommendation of fits keyword, that all the fits keyword are right there to for the coordinates to place the sun correctly. It's also immediate to have it displayed in GLO Viewer. And also there is at the last point, I don't have a pointer, but so there is the ResiFlare, which is another TAP service, which can also be included in GLO Viewer, which means that the event is somehow displayed on the image. So here we have catalogs, we have images, we have table access protocol that all can talk to each other. So at KISS, they did a similar thing. They had to also curate highly inhomogeneous data sets. So this is a bit the same as what we did for the review of the metadata. But so in particular for high-resolution ground-based spectropolarimetric data set, they uniformize the way it was described. They created an instrument independent importing framework once this was done. And they have an archiving of the data. So this is high resolution data. You have some screenshot over there of the archiving data center. And they begin to implement the EVOA standard, and in particular, they want to publish the information about the ground-based solar data in EPN-TAP. And this is really in preparation for EST, because this is high-resolution ground-based telescope. And again, once this is in EPN-TAP, we can immediately include them in the SolarNet VO, rather than doing that as a side. So all this standardization and being into placing everything into a VO framework allows to simplify somehow the work at some point. So yeah. This was a pioneer endeavor for the ground-based high-resolution solar community. Thank you.
I thought you had another slide or two.
Oh, yes, that's true. Oh, sorry. Yeah, because I saw the time, that my time was up. Yeah, so actually I said a bit that we want to more integrate, right? That if we have SolarNet fits keyword, if we have TAP, and if we have, then once everything is into an EVOA standard, we can easily import them to a dedicated virtual observatory, to a visualization tool, and also to some tool, Python Access. We use a lot Fido in our elements, but this is easy once everything is put into a standardized VO. And it's true, I had the last one, the most important. I hope you enjoyed the solar eclipse. Thank you.
Okay, going from solar physics to gravitational waves, I invite Giuseppe Greco to make a presentation. There you go. So you just press the big green one right there.
So thanks, and I am very, very happy to have the opportunity to show the results from the CIVO Virtual Observatory ESCAPE in the context of the EGO and Virgo collaboration. So just a few words about the EGO and Virgo collaboration. Virgo is located very near Pisa at Cascina and hosted by the European Gravitational Observatory, forming the so-called LIGO, Virgo, and CAGRA collaboration, in short LVK collaboration, with the two LIGO interferometers in the United States, Virgo in Italy, and CAGRA located in Japan. And in the last 10 years, approximately, the LVK collaboration has collected a very large number of results and scientific discoveries, with the birth of the multi-messenger and gravitational wave astronomy opening a new window in the universe. And just I stress the first gravitational wave detection, the event GW 150914, and the first multi-messenger observation with the gravitational waves and electromagnetic counterparts, the event 170817. And of course, in this year, several general relativity tests have been performed. And the virtual observatory has supported the very large effort from the multi-messenger community, developing a sophisticated method and practical approaches in a short time. And I think this consideration is very, very important, considering the fast growing of the multi-messenger science in a short time. So in more details, the popular virtual observatory standard named multi-order coverage map has proven to be extremely powerful to encode the complex region of the gravitational wave events. It means the users can query the entire IVA collection in this complex region in a few seconds. And the first tool in which this new technology has been applied is Aladdin Desktop. And in fact, in the official LIGO Virgo Cagra public alert user guide, you can find a very large section dedicated to the Aladdin Desktop in the environment of the multi-messenger science. And in supporting the next observational run, namely 04, at the beginning of the next year, we added additional 2 sections about Aladdin Light, focusing on the multi-order coverage map in space and time, as discussed in previous talk by Mark. So MOC 2.0. And here we can see the space and time intersection simultaneously between, between the GW scale localization provided by LIGO and Virgo, 170A17, and in yellow, and in blue, the error box of the gamma burst 170A17, of course, provided by the GBM instrument on board of Fermi satellites. We use also modern web technology, in particular developed by the CDS team, and they are Aladdin Light and the WebAssembly library named MockVasm. And from this marriage, from this combination, we develop a new web tool and able to organize all the schema released by the LVK collaboration, both in low latency, in real time, using the button alert, and in post-processing analysis, using the button catalog. And of course, there are also additional functionality to locate electromagnetic transient candidate and perform dedicated operation in localization visualized into Aladdin Light. And most recently, we also published an article in Astronomy and Computing in order to discuss the ability of the multi-order coverage data structure to plan multi-messenger observation in order to reduce the duplicated images and save the telescope time. So as an example here, we can see the visibility evolution of a gravitational wave localization, GW 190425, in 3 different observatories around the world, Hawaii, Australia, and Chile, in order to construct worldwide collaborations. So we use this approach in several contexts. As an example, in the Virtual Observatory School, in the LIGO Virgo Cagra Open Data Workshop, in Science Festival, using Aladdin Light or Aladdin Desktop, also for press release and news from the LVK collaboration. And in particular, in the University of Perugia, we teach IVOA standard in multi-messenger context, proposing also dedicated research thesis. And it's a very, very nice feedback from the student. So what's next? And so the ESCAPE to the future, and just a few words about the next generation of gravitational wave observatory, and in particular, Einstein telescope. It is approved for ESFRI roadmap 2021, and the simulation shows that Einstein telescope will be able to detect approximately 1 million of merger between 2 black holes per year, and 10 to 5 merger between 2 neutron stars per year. So a very large quantity of the data, and most of them can be sent to the astronomy community before the merger time. So for that reason, we try to discuss a new IVOA implementation, a funny name, Material Sky, but it's just an idea. So we need the efforts and professional quality of the VO and the IVOA team. So many thanks. Thanks ESCAPE, and thanks CDS team for friendly and professional support to EGO, Virgo, and LVK collaborations.
Thank you very much, Giuseppe. A whole new area of astrophysics coming out there. As the last talk, I invite Mark Katenis to the stage. And the magic wand here. Press that big green button.
To go on. Yeah. Okay, thank you, Mark. So my talk will be about radio astronomy again. My colleague Des has already given you an overview of what JIVE and the EVN are this morning. But important for this talk is actually that JIVE also hosts the data archive of the European VLBI network. We've had this archive for quite a while already. It was one of the things we did fairly early on when JIVE was founded about 30 years ago, I think. It has been a little bit more modernized, but I think it has been in this shape for most of the last 15 years. It's a searchable archive. Most of the data in the archive is actually public, although also the data that is still proprietary because it has been recently observed and our PIs are still working on it. It's also in the archive. But yeah, it's heavily used by our users, so heavily that they sometimes complain that the search facility is actually a little bit slow. It's fairly fair, but I think one of the missing things was that it was not very findable. At some point, it's included in the ra3data.org catalog of data archives. But we had the feeling, at least at JIVE, that to be properly findable, an astronomical data archive actually needs to be visible through the VO. So you can think of some use cases. One possible use case is access to historical data for high-resolution follow-ups of extreme universe events. The EVN has been quite successful in locating and repeating fast radio bursts, lots of observations of gamma ray bursts, and was also involved with the electromagnetic follow-up of the first gravitational wave detections. But another possible use case is actually to use the VO APIs to actually provide data access of a science platform that we're developing. And more about that later this afternoon in the talk by Art. So when we tried to do this, one of the things that was immediately obvious is that VLBI data is different from most of the data in the VO. Most of the data in the VO are images, but in VLBI, making an image of your data is not an exact science. Because of the way our array works, our what we call UV coverage is incomplete, which means that there's multiple possible images for the same set of what we call visibility data. Now, the VO already had the possibility for visibility data, but not a lot of visibility data that was actually active. Now, a nice example of this principle is actually a recent image from the Event Horizon Telescope. So this is not EVN data, but it nicely illustrates that from a visibility data set, it's actually possible to construct multiple images, and you actually need to do a thorough analysis of your visibility data with different algorithms, different parameters, to actually decide what's the most likely image. And that was done in this image of Sagittarius A star by the Event Horizon Telescope. Another issue is if you have visibility data, some of the observational properties are not very well defined. So for example, if you have pixels, then the footprint of that observation is pretty easy, but in VLBI actually the footprint of your observation depends on several parameters in your imaging algorithm. And if you are looking for really bright things, you can actually image a much wider field of view than if you are looking at fainter sources. And another aspect that we struggled with is that a VLBI dataset is not a single, typically not a single source, but actually multiple sources per observation, and those additional calibration sources typically are important actually to be able to do the imaging. So during the ESCAPE project, we had lots of discussions in the CIVO context, but also in the IVOA context, about what the best way to actually represent visibility data, our field BI observations in the existing IVOA standards. So through CIVO, we also got quite heavily interaction with the IVOA, the radio interest group in particularly. I think CIVO was one of the key players there to get that off the ground. And we've contributed several things already. So we've contributed to an implementation note that has been written and led by, amongst others, François Bonnerel, who's here. And we're also contributing to a radio extension to OpScore, where we think we can have define some additional parameters to actually characterize the UV data set a little bit, the visibility data set a little bit better, such that you can do a query and select the data sets that you actually are likely to be able to get an image out of that is sufficient for doing your science. The protocols that we implemented in our VO service are OpSTAP, which is the table access protocol serving OpScore metadata of our observations. And we also heavily use the data link protocol that we basically use to link together the parts of our data sets, link them to calibration information that you need to actually process that data. And in the future, we hope to actually also link preview images that our pipeline produces and diagnostic plots to the data set, such that you can see that data or download that to see whether it's actually worth investing your time as a scientist in trying to image that data. Our service is based on a piece of software called DAX, but we had to write some custom software to actually grovel through our FITS IDI data to get out all the relevant metadata, because not everything is in the FITS header of those files. And this service actually runs on top of the existing archive, with data link providing links directly to the existing archive server. When you put it all together, you still need to publish the service to actually make your data findable. Fortunately, DAX conveniently implements a registry, so we can have our services that we provide in our own registry, and then we just have to publish that registry to the registry of registries of the IVOA. And once you do that, once you take those hurdles, you actually see the EVN data archive show up in, for example, Aladdin. And here is basically, I don't know if it's visible on the screen very well, but basically an overview of all the observations public observations in the EVN archive. And the astronomers amongst us will be able to see the galactic plane clearly show up here as in most all sky or half sky archives. So some conclusions. I think that CIVO has been very instrumental in involving not only JIVE, but getting more astronomy, radio astronomy observatories interested in publishing their data on the VO. A lot of them are producing images, publishing images, but we are now also publishing visibility data. And I think it's also interesting to see that we are actually already running services on top of our VO APIs. And the nice thing is that searching the archive using this service is really, really fast. So that ticks off one of our users' complaints. Thank you.
Thank you very much, Mark. So we have some time for questions. So let me see. One thing just to stimulate your thinking here. I mean, one thing that impresses me about the work that the partners have done in this type of project is to use the tools to build on them for their own particular needs and requirements, and to feed off each other for how to make those improvements. I think for me that's been really eye-opening, the way that part of the team has worked together. There's also been a lot of interaction with the other work packages, with the software repository and the development of machine learning techniques that have been applied, with the testing of all of these types of virtual observatory services through the platform. We've shown some of the virtual observatory astronomy tools here, but to have those services also available in the more generic, the wider reaching Work Package 5 platform has been really interesting. So from gravitational waves to solar physics, I open the floor for any questions to the panel who have spoken today.
Thanks. It is on, yeah, it's fine. I have a question for Mark, I think. So for the Jive work, and you've been looking at getting the visibility data working well with the IVOA, have you also explored how those users of that archive data might put their, like the corresponding images that they make into the right formats?
We've at least been thinking about that. So one of the plans we still have for our archive is to actually making it able to ingest basically the results, the images that the PIs or other scientists produce and write papers about, to re-ingest those in the archive such that we have that image data in the archive. That is, of course, something that needs interaction with the users and hasn't gotten off the ground yet, but it's certainly one of the things we plan to do. With my Event Horizon Telescope collaboration hat on, I've been also involved in actually publishing the Event Horizon Telescope data back into the ALMA archive. I think that the way the ALMA archive operates there, that is a good model for how to do that. So if you're interested in that, look at that.
That's a really interesting question there, and I wonder, I mean, the model of the observatories or the instruments make their data archives, make them interoperable, but then there's the loop of the processed data or the value-added data by the authors who they might publish alongside of a paper. ESO, for example, has the phase 3 process. I wonder if you want to comment on that, Martino, whether that's you can advertise from the ESO point of view how that type of different publication of data works. Yes. Would you advise others to do it?
Yes. From a science point of view, you have to do it, that's clear. You cannot produce yourself as an observatory all that is interesting, that's clear. It has to come also from somewhere else, even because there's also different quality. I mean, an observatory usually can concentrate on the bulk of the process, something that's good for genetic purpose. But then the scientists individually have looked at a specific question, made the data for that specific answer. So that I think you need to do that. Now, the cost of this is mostly social, I would say, in the sense that, as we've said, you need to make the data interoperable, otherwise there's no point in storing the data, just, it's storage, it's a bucket. And that requires asking people to comply with standards. And that, trust me, is at times challenging. But they need to see the advantage of that. What's in it for them? If you can show that, then it's a much smoother process. And it works at the end. We've been doing it for 15 years now, and it works.
So I think Francois had an additional comment on that
Yes,
subject.
for this kind of interaction, I think we have to understand that the work done in CIVO between the ESFRIs and the so-called VO experts, such as Edinburgh or Heidelberg or ENA for us at CDS, is in two directions. So for, as you said, the VO standards, they are also in constant evolution. And so when you try to map the data from a given S3 to the VO standards, of course, the VO experts, they have to help the people to figure out how we can do that. But one of the results is also that from the VO side, we understand we have to make some evolution, and we have to make some extensions and change a couple of things in our standards in order to better tackle this kind of data. So it's really a two-direction process.
See another question, Matthew
You
Servia.
can see that on all the presentation which has been made.
Another question by Matthew Servia.
Yes, I wanted to mention what could be an outcome of CIVO as well. Following what has been done in the radio astronomy interest group at IVOA, as you said, you don't have just images. We also discussed in the high energy level, different observatories from high energy, that we don't have initially images. We collect photons. We have lots of data for just one photon sometimes. And while we started this effort a few weeks ago to try to model what this high energy event is for each observatory and try to go further with the standardization of this, connect not only images but also our list of photons. And I also have one question, is that as data providers, do you consider to produce some provenance database or expose some provenance particularly?
Well, I can see SKA nodding, so I wonder, can you elaborate on that, Antonio? No, we can't elaborate on it.
It's just a big yes.
Okay. Sylvania, did you have a question yourself?
Yeah, I do. Is there another?
It's the R and well, actually, see, you know, fair is reusable. You know, the R in fair is reusable. There is, I mean, it's an important distinction actually, because I mean, reproducible is, I think, a really high goal to aim for, something that we should do in science, of course. But in the discussions of fair, keep in mind there's reusable and then there's reproducible. We do a lot of reuse. It's just being demonstrated in the ESO archive. Reproducible means you have to, you know, do you have that science platform? Do you have that workflow that someone can rerun? Okay, I've simulated a question now.
Well, no, I mean, absolutely, you're correct. And, but, you know, anything is reusable. But if you want
to make it reusable, I can tell you.
If you want to be reproducible, then the provenance data is crucial.
Yeah.
I think that's the point I want to make.
Okay. Maybe last question.
Can I make a question? I will make a question, take advantage of the presence of Giuseppe here, about Einstein telescope, a little bit farther than the virtual observatory, if you feel like to answer. I was wondering the following. It's great that you also consider the virtual observatory for the advent and the perspective of the Einstein telescope, but once we have in front of us a new project like Einstein telescope, the same as for the future circular collider. So you are going to enter in the design study phase, you are going to enter a long preparatory phase. We know that we have other important technical tasks, but we know also that we have shortage in the resources and you have to define priorities. Now I come to the question. in my opinion, the ESCAPE contest, or whatever we are producing, the so-called virtual research environment, whatever, the data lake or other components, should be really ideal for you to host any kind of efforts of a newcomer like Einstein Telescope. I'll give you an example. If you want to make accessible fair, also a sort of toy simulation environment to collect the participation of further scientists to explore the sensitivity of Einstein Telescope, you have the environment, you have all the bricks. Are you considering all these perspectives and others in the Einstein Telescope right now?
Well, right now there are several subgroups in Einstein Telescope, cosmology, electromagnetic follow-up. So in particular now we try to study the synergy with the second generation of interferometer with the Cosmic Explorer, the new interferometer in the United States, and with the Einstein Telescope in order to understand how big is the schema of Einstein Telescope. So we are working on that with the synergy, for example, with the high energy synergy, most probably with the Fermi satellites. We also try to study how many detection about the macronova with the Vera Rubins. So we try to combine several community in order to organize and centralize the electromagnetic follow-up in Einstein Telescope in order to reduce the time allocated for each telescope and observatory. So we try to work in this direction 10 years from now.
I think in the last 3 seconds.
Yeah, super. Okay.
We can thank everyone.
Thank you, Mark. Thank you, the speakers. Round of applause. Thank you. Swiftly on, I would invite John Swinbank to come down with his set of speakers as well to join the panel. We'll do a quick turnaround with water and name places. Thank you very much, Rita and Livia. Whilst we were doing that, sorry, just to make the time over, I don't know if we didn't have a question online, but I did want to speak to Martino actually during the break around the Federation. As you might know, one of these sustainability task forces is on funding models, which gives everyone a headache, but it's divided between exchange, core, and data federation. So I think it would be interesting also to include in the next iteration of the report in 2023, the example that you were giving before. So maybe we can pick this up during the break. Okay, so hi everybody. And hello, John Swinbank, who is the Science Data Center Program Manager at Astron. I'm going to pass you the floor immediately so we can get started. Thank you very much.
Oh, is it still on the same deck?
And the session title is Common Standards to Access and Use Data with a Science Platform Toolkit.
Thank you. There we go. All right, good afternoon, everybody. Thank you for giving me the opportunity to talk to you today. So, as advertised, I'm going to introduce and give you a brief overview of the work we've been doing in Work Package 5. And then I will try and get out of here relatively quickly so that I can hand over to these guys who are going to tell you a little bit more about how this stuff is actually useful in practice. So, as mentioned, I'm the Work Package 5 coordinator. I'm not going to do an elaborate set of thanks for this, but I do want to make clear that coordinator is really the right word here. I'm not the brains behind all this. It is the collected members of Work Package 5 here in the room and online who have made all this happen. I am just the face and the voice that is here to present it to you. So full credit to all of the partners. You've seen this diagram a couple of times already today, I think. This is the ESCAPE cluster showing how all the pieces, all the different work packages fit together. You'll notice in the top center, highlighted by a nice red square, is ESAP, Science Platforms, Workflows, Notebooks, Deployment Platforms, Packaging. Lurking behind that, it says RI-specific science platforms, and even above that, TSPs, although TSPs has got cut off, not quite coincidentally by my little red box. We're going to hear a lot about TSPs tomorrow. So here I'm really focusing on the RI-specific platforms. Really the model that we're going for with ESAP is saying, well, we've got this kind of diverse service offering from all the other work package you've been hearing about today, everything from data lakes through virtual observatories, software repositories to citizen science. But what we want to do is bring that all together and present it to the end user in a way that helps them actually get their science done, rather than them worrying about the technical details of all these different systems. And at the same time, while we're doing that, we're conscious that the science cases, the user communities of all the different research infrastructures are different. They all have their own needs, they have their own pieces of data services, archives, whatever it is that they're bringing with them. And ESAP is an attempt to bring all those together to form kind of one coherent whole. So the way we think about that in Work Package 5 is really as twin missions. So first, we've spent a lot of effort developing ESAP itself. ESAP is the ESFRI science analysis platform. When you are bored, you can sit down and expand all the acronyms in ESCAPE ESAP, and you'll need a very long piece of paper. But ESAP is then a toolkit for building science platforms, where those science platforms let users discover and interact with the data products, tools, workflows, services, etc., that are coming from the other ESCAPE work packages, but potentially also from the wider environment that the research infrastructures are existing in. So with one hand, that's what we've been doing in Work Package 5. With our other hand, we've been working directly with the ESFRIs, with those service providers, with those folks who are making data products, etc., and helping them present those services, products, etc., in a way that they can integrate it with a platform, that they can bring their services to the user through a platform as we enable with ESAP. There you go. That was clearly worth fanfare. All right, so the ESAP software itself. This is really what I want to focus on for the next couple of slides, the technical details of that platform. And the idea here is that ESAP provides the focal point for integrating those services from a range of different providers. So we have software that provides does this provide me with a laser pointer maybe? Yes, it does. So we have these two boxes here, the graphical interface and the so-called API gateway, are the major components that you can come to Work Package 5. You can check these out from our Git repository. Very soon you will be able to find them in the OSSR and get them from there, of course. And once you've got those, they help you map between your end user and this whole network of different types of services here, where those services then map onto the various work packages. So they'll give you seamless interfaces between, say, virtual observatory services or maybe Zooniverse citizen science databases onto Binder and Jupyter systems that are letting you access notebooks or other software that you're pulling from the OSSR, onto the data lake or potentially other storage systems. Onto bulk computing systems like Dirac that we heard about earlier. The idea is that then ESAP is extensible. It's a pluggable system. We won't give you the means to connect to all of these things, but we give you a standardized way of connecting to these things, and you can extend ESAP to connect to whatever the particular services in your research infrastructure are. So if you have a special compute system or a particularly unique archive that doesn't go through the virtual observatory or something like that, you can write a plugin, you can plug it into the overall ESAP infrastructure, and then you're up and running and it integrates with everything else. So the idea is that we provide you this customizable, flexible, pluggable backend. Research infrastructures pick that up, deploy it, and provide it to their customers or their users. This is a very brief selection of the sorts of capabilities that you get through ESAP. This is by no means a complete list, but you come to ESAP and you're hitting this kind of reasonably nice web interface built on Python and Django, all kind of modern web technologies, but that lets you talk to a bunch of different archives, including virtual observatories. It lets you load and execute software that's pulling from the OSSR, that's letting you orchestrate your batch computing and your interactive data analysis across a bunch of different services. That, of course, is providing deep integration with virtual observatory tools through services like SAMP, etc. But that list is by no means finite, because you can keep adding plugins, you can keep extending ESAP to address whatever it is your particular needs are. And I think at that point, it's a good idea for me to hand over to some of the folks who are actually doing that for real. So we have 3 special guest stars in this slot. And I think they actually make an interesting bunch. I will kind of introduce them each one at a time, but I want to give you a brief overview that I think is really interesting, that we're hearing from 2 ESFRIs, CTAO and SKAO, that are really just getting going, that are thinking about how do we build on ESAP and on other technologies, and as the observatories come online over the next years, how do we use them to provide services to our users? How are we building on this going forward? But we're also going to hear from Jive, and I'm really excited about that because Jive are doing this now. Jive are not saying, what will our observatory look like in 5 years or 10 years? Jive are saying, we have scientists now. How can we provide them with services that are interesting to them already? On that note, I'm going to suggest, I think Matthias is up first. So you've been introduced to Matthias already today, but Matthias is going to tell us about the CTA experiences with ESAP. Take it away, please.
So thank you, John. So one thing that I would like to report is on our experiences from CTO to work with and for ESAP. But I should say, as John is the face of the whole work package 5, I'm just the face of these contributions. The work was mainly done by Gareth and others in that work package, actually. But okay, I won't go into the details of the observatory anymore, of CTO, just saying that one of the key elements of CTO is obviously to provide the user community with access to the data and the products and service that CTO provides. And for this, we need a science portal, where our users get access to data and science tools. And this now comes together with the ESAP that offers actually building blocks to build such a portal, and even platforms, because I specifically say here portal here and platform there, since the access to computing, which is for me a platform versus a portal, is not yet decided for CTO if that is also offered, but this also depends slightly on the experience that we will develop with using ESAP as the main building blocks to build such platforms. And we are able, or have been able in this project phase to actually explore certain workflows for us, so CTO users that would like to execute a certain science analysis on a platform, or thinking about our own CTO staff that wants to do data management tasks using such a platform, for example, batch processing, or also thinking about more broad community interactions like science data challenges, where the interactive part is much more important. So if you now if we now start simple, then ESAP provides a platform to add services. So if you have a data source, you can just simply add it, or if it comes with the REST API, the service can even be added to and queried through the ESAP. And what we have been doing is we added this library from developed within the OSSR to actually access the Zenodo. You can here query then the CTO community, and via these keywords you discover the elements here, for example, the instrument response functions that have been put on Zenodo for CTO, and obviously you can do these kind of searches, and it's just available from the top menu bar here as a panel. Now moving further towards more elaborate questions, so here's the main menu bar of actually the ESAP platform, so we are moving here from archives to interactive analysis, and this is what also ESAP facilitates, the connection of software data and computing to provide interactive analysis, and that is something that our CTA Science Portal might also offer. So users will be able to interact with the data, but they will also, for example, it would foster cross-collaboration and joint analysis. And if you think about multi-messenger, for example, the field where I come from, in astrophysics, so current ICT experiments who are working as experiment style, normally they start interacting after the first data have been published. And this might trigger, for example, in case of upper limits, questions like how the upper limits have been calculated anyway, and then they start comparing, and that takes quite some time instead of just having here platforms to jointly collaborate on creating results in the first place. But also that could be used by observatory staff, obviously, to just do basic tests like data quality checks. So what we have been doing here as a test case, we use these open community tools, GammaPy and AGNPy, one to model AGN data, want to analyze it and fit them. We plug this together and then added here such use case. So the workflow is you search for the workflows that the software offers. You select then the compute facility on which it should run. Then you spin off a Jupyter Notebook environment on Binder Hub, and you have here a Dockerized container that contains tutorial scripts that you could and workflows that you could execute on this ESAP platform. And for example, here with AGNPy simulate data and with GammaPy then analyze them and fit them to get a broad SED, for example, here for a modeled AGN. Yeah. So one of the things that we have not been able to do yet was this data here is actually contained as part of this containerized environment. So the link to the DIOS to actually get the data from there and store it back, this interface has not yet, we were not yet able to add to the ESAP functionality, but certainly this is something to do in the future. So moving on now here, one more menu item. Now we come to batch processing. That is a key task for CTO essentially to do internally to manage the petabyte scale of data, to automatically process it to higher level data, do the data quality checks. The data might be spread across multiple data centers in a data lake environment, and CTO staff needs to be able to launch such data. And this API using here Dirac, which is the workload management system that CTA chose internally, and you've heard about this Dirac already as an interface to the DIOS in processing. Here's the other side of the interface to connect it to the ESAP platform, has been implemented here. So here you have the two main functionalities to submit batch jobs and to monitor batch jobs. And essentially this interface, as it is existing, could be customized by whoever runs their own Dirac instance and just use it. And the workflow that we implemented is shown here. So you can search for different workflows, and just for the fun of it, we took the Concordia example to some that have been mentioned before. You search for the workflow, then you deploy it to a certain Dirac instance that has been here registered in this. From there, you might be able to, as mentioned before, easily change the configurations of the batch jobs that should run, and then you submit. And yeah, this is nicely working. And here you even, since this is also using asynchronous ways to access, to spawn the jobs, you can also then here have a menu item to monitor the processing of the jobs. Here all have been completed with different items, and you can here even go to the archive to check the responsible or the respective data. And obviously there's two items that I would like to mention here that are important. One is that obviously tokens so is always an item here. So also when talking between ESAP, Dirac workload management, and DIOS data lake. So this is one thing where I think things will move and converge. The other thing is to achieve that, you also need a description of the computing. And this is something where IVOA and CIVO now come into place to correctly describe the workflows and the compute levels and have appropriate metadata so that it can be steered from such a platform in a more general way. Then the last item that I would like to mention is that using the ESAP was also having in mind potential use for a science data challenge where you engage with a broader community. And one of our colleagues from one of our data centers was investigating this platform. So he took it, then customized it, deployed it, and rumors had it that he did this within a couple of days. So he's also here today, so if he's that good or just the platform is such easily deployable, you can find out yourself by talking to Volodymyr. Otherwise, he was also able to extend this even and add, for example, here certain metadata for the different workflows so that you can easily, by, for example, searching for these metadata items, identify those parts of the science data challenge that you would like to do. And for actually doing then the real collaborative work, here the challenge would be that the workflows would be made persistent, and that is also a functionality that is more for the future to implement. And that was already it, the overview, what we've done as contributed. So ESAP provides for us an excellent toolbox so far. So we were able to implement certain different workflows from interactive to batch processing, and also have been able to deploy this from colleagues that have not been involved in ESCAPE before and were just new to it. And there were several topics still open, and we are looking forward again for future collaborations on these topics, that's for sure. And this time I'm not going to miss to also show the contributor slide. So thanks to these people. And
thank you, Matthias. So next up we have James Collinson from SKO.
Let me just see if I can work out how this works. Just one button, nice and simple. Okay, yeah, thanks very much for the introduction, John. So yeah, I'm James Collinson here from SKO. I'm an operations data scientist there, based at our headquarters in Jodrell Bank. So I haven't got an acknowledgement slide, but I'll say this is on behalf of all of Rosie's team at SKO, so including Rohini Joshi, Rob Barnsley and Alex Clark as well as obviously our collaborators across the ESCAPE project, in particular at Astron and CERN. So today I'm going to talk to you a little bit, give you a quick summary of some of the activities that we've been working on in the ESCAPE project, particularly with respect to ESAP and the technologies related to the future SKA science platform. So I'll set the scene with a bit of background to the ESCAPE project and talk about the SRCs and why they're so important to our end users in being able to deliver their science. So the SRCs are this distributed network of data centers that are how the astronomers will interact with their SKA data. Then I'll talk about the prototyping activities that we've undertaken as part of ESCAPE. So I'll try and relate these back to the SRC capabilities and architecture to show where they fit in the bigger picture. And finally, I'll touch on at the end, the wealth of other benefits that being part of the ESCAPE project has brought us, not the least of which has been the access to all of this, the expertise within this room. So the SKA the ESCAPE project will develop, construct and operate the two largest radio interferometers in the world. So the SKA mid-interferometer is being built in the Karoo Desert in South Africa and will comprise 197 dishes. And then the low interferometer that's being constructed at the Murchison Radio Observatory in Australia will comprise some 130,000 antennas. So the low interferometer operates at a frequency range just a little below that of the mid-interferometer. But there are already precursor instruments and associated projects that are already collecting data, but our science operations won't formally start until around 2028 for an initial project lifetime of around 50 years. So the SKA low array is, as I mentioned, a fully electronic telescope. So all of the pointing of the beam on the sky is controlled by electronics and software basically sat within the arrays themselves. So those electronics form an initial data reduction of the raw data rates of around 2 petabits per second to reduce those raw antenna voltages into signals that are ingested into the central signal processor, which there is a central signal processor for each array, and these produce some of the higher level data products like visibilities and transient candidates that are ingested into the science data processors. So science data processors do supercomputers that will actually output the observatory data products into the network of SKA regional centers. So a reasonable upper limit for the data rate flowing from the data processors into the regional centers is of order 100 gigabits per second per interferometer. So in addition to showing that this is a big data science project, the key point here is that the SRCs are the point of contact for astronomers. So they are how we will turn SKA data into science. So that brings us on to the capabilities that the SRCs will need to have, but I think for the purposes of this presentation, we can focus on just a subset of these. So the user, first of all, will need to be able to discover the data, sort of regardless of where it is physically located. and they should be able to use sort of some of the well-defined standards like the IVOA standards to interact with that. So when they've discovered their data, they'll also need to be able to stage compute at the data locations so that they can run customized scripts and notebook kind of workflows to interactively analyze it depending on their particular scientific interest. Then there'll be a related but separate capability related to bigger batch workflows. So these could be the user wanting to scale up an interactive workflow across a larger set of data, or it could be for the observatory to generate advanced and project level data products from some of the observatory data products. So we'll need to be able to deploy these kind of workflows on bigger compute clusters. Then, of course, the backbone to all of these activities is the data management tool, which we'll need to federate our data lake across the sites, the SRC sites, both to maximize data storage efficiency and data integrity. So if we now have a quick look at the logical view of where some of the components that enable these capabilities sit, the users will interact with a science platform, which will query an API layer, and that in turn will forward queries onto particular services, such as the data management tool. So ESCAPE has allowed us to identify some early candidates for where these might sit. So in particular, for instance, Ruscio is a candidate for the data management tool. Indigo IAM handles authentication, and ESAP really sits here at this top sort of user-facing level, which brings together these various different services into a more centralized location. But I should point out here that these aren't the only candidates that are under consideration, but that's just where they would sit in the logical view. So that's the very high level. Let's now drill down into some of the specifics of what we in the SKA project and collaborators have taken towards enabling this functionality. So on the ESAP front, the SKA didn't initially have and still doesn't have any data archives, but some of the precursor instruments I mentioned earlier, that Jan was talking about earlier, in particular LOFAR, do have those existing archives, and so collaborators at Astron have been able to integrate those into the ESAP front end, into the data discovery services. So that's a nice sort of proof of concept of how these archives can be structured to enable maximum versatility. At SKO, we were granted access to STFC cloud compute resources for prototyping early SKA SRC workflows. So to manage the user interaction with these cloud resources, we deployed a notebook platform based on Jupyter Hub as a proto-science platform for, like I say, testing the early SRC-like workflows. So initial improvements to this vanilla deployment included integrating with the ESCAPE Indigo IAM instance for authentication, and then providing persistent storage so that you could more easily mount larger data volumes for testing workflows on bigger data. So we also needed finer control over the software that these environments spun up. So we deployed a binder service, as Matthias talked about just before, and that can dynamically spin up notebook environments from code-compliant repositories. Simultaneously, we deployed an instance of Ruscio, also at STFC Cloud, to further enable us to run data transfer tests between some of the SKA telescope sites. So this includes data centers in South Africa and Australia and a number of other SKA partner countries, and we developed an automated test framework to do end-to-end testing of the full grid of sites to make sure that we could identify and flag through a monitoring stack problems as and when they occurred. So why am I talking about Ruscio in this sort of ESAP section? We heard about it this morning. Well, more recently, we've been able to integrate that with the Jupyter Hub prototypes. That sort of integrates Jupyter Hub with Ruscio, using technology developed at CERN initially to replicate the so-called data lake as a service. So that's obviously a key step in the direction of bringing compute to the data, which is a key goal for us in particular, as is, I'm sure, a lot of our collaborators in the ESCAPE project. So that brings us to the current state of the SRC network prototyping. So from 2022, this global team of teams has formally started work to develop and build the prototypes as the first stage of their wider development. So ESCAPE candidates are now being expanded and more widely tested by this bigger community. So we've deployed an SKA-owned Indigo IAM instance for authentication for the SRC network, and also have been onboarding additional Rusio storage sites. There are some additional Jupyter Hub instances that are also going through the process of integrating with that Rusio instance. And this is all on top of the expertise that this group already has in some of the precursor data analysis infrastructures like ASCAP and LOFAR. So ESAP itself is a candidate for further exploration in the science analysis platform prototype stream, and a number of the ESAP developers and contributors at Astron are directly or indirectly involved in this prototyping, in these prototyping activities. So it's worth pointing out here that, obviously we're a ways off SKA data delivery yet, but we're hoping to be able to use the science data challenges that are sort of the initial point of contact with our user community to test early systems. So for example, we're currently using Rusio to form part of the distribution of SDC3, Science Data Challenge 3 data to sites supporting that challenge. And we plan to take advantage of these as opportunities to get that early customer feedback from the user community and test these early systems. So before I wrap up, as I promised, it's worth mentioning, a range of the other benefits that being part of ESCAPE has brought us. So first and foremost is this network of experts that we've been able to work with and learn more about these technologies as we collaboratively solve some of the challenges that we all face. So we've also been exposed to a wide range of lower level technologies like Kubernetes and some of the CNCF technologies that are becoming increasingly ubiquitous, both for our fields and in industry more widely. We also have delivered a bit of value back into the Rusio community through the automated integration testing that I was mentioning earlier. So these, in particular, highlighted early issues with the OIDC token kind of authentication flows that hadn't been picked up through sort of more unit test focused campaigns, but they led to upstream improvements in the Rusio code base. So it's worth stressing, I guess, the value, these complex multi-component systems with lots of different microservices, worth stressing the value of those end-to-end integration tests to really make sure that it's working as expected. So I think that's all I wanted to say for today, but thanks very much for listening.
Thank you, James. And I have to say, from the point of view of the WP5 mouthpiece, as I said earlier, it's actually really exciting to see the work that people have been doing in the ESCAPE collaboration over the last couple of years suddenly becoming real as we hear from CTAO and SKAO how they can push it forward. But what I'd really like to do now is invite Ard to come and tell us a little bit about some of the things that are really being deployed and used now as opposed to in a couple of years.
Does it work? Yes. So I'm going to talk about the EVN archive portal. So I want to skip the introduction of Jive, that has been done very well by Mark and Des. So to set the stage a bit, so here I show the annual amounts of archivable data for a number of instruments and on a logarithmic plot nonetheless. And you can see basically I've sorted them in yearly volumes, but you can actually see this as more or less as a time axis where newer instruments actually keep producing more and more data. And the SKA, this will come online of course somewhere this decade hopefully, that the last estimate I've heard of that it will be kind of like a petabyte of data per day, so that's a lot of data. And well, in that kind of environment, of course, it's kind of a no-brainer that you want to bring the compute to the data rather than the other way around. But unfortunately, it didn't always used to be that way. And so when we started out with this in our domain, in VLBI, actually, you basically have two flavors. Basically, the kind of software you can use interactively on your local machine, where you just download your data set to your local machine and just do all the processing there with your little mouse, or you do it remotely, but then using some fully automated pipeline where you basically set a few parameters and then come back a couple of hours later. And very often that is exactly what you want. But also, to get the most out of your data, you also very often, and especially in VLBI, you very often do need to actually really go have interactive, basically have interactive access to your data to get the most out of your data. And that is, at least in VLBI, that is a very essential thing to have. And So very early on, we decided on that Jupyter notebooks would be the way to go because, well, of course, everybody is familiar with them. They're very user-friendly, and basically every step of your data processing chain will be in your notebook. So you just have basically one online document that have all the steps that have your data processing in them, and that's a very powerful thing to have. And still, the interactivity is actually still optional. You can still do batch processing with Jupyter notebooks. You can just still run them from the command line. And I also think I will really highlight one of the things I think is also really good with the Jupyter notebooks is that the added accountability. Because if you actually do all your work in this kind of environment and you have a certain result, and give someone else your notebook, they only have to press run and should be able to get exactly the same result back. So it really aids accountability, we feel. So we have created a Jupyter Hub service at Jive. And this is a fully open service. So anyone who is interested in reducing some data from the Jive archive can sign up for a free account. It's available from jupyterhub.jive.eu. It's up now. And this service really builds on the results we have done in the work packages 3 and work package 4, as I will show you later. So one thing also we have decided on very early is that actually we do not want to store any user credentials, so no username, passwords. So we only want to use external identity providers. So of course we support the ESCAPE IAM, so anyone with an ESCAPE account can just log in right now. But for people from outside of the ESCAPE community, we're actually now applying to get EduGain access, and which basically means anyone with an academic from nearly any academic institution around the world will be able to log into our service using their own credentials at their home institute without any of that data being stored on our service. I think is really important from a security point of view. And on top of this, there's actually also like a second way of approaching our archive. You can actually also go to our Jupyter Hub via the ESAP. So if you go to the ESAP GUI, there's actually one of the facilities you can run your ESAP workflows on is actually our Jupyter Hub service. So also something, of course, that's very important is that you adhere to FAIR standards, so the data is findable, accessible, interoperable, and reusable. So it's been said many times during this meeting already. But we achieved this primarily through the fact that we're now in the VO, so that contains all the metadata of course, gives, it contains all the metadata to all our observations. Makes it very easy, a very powerful search engine that people can find data within our archive. And actually show that we actually have even created a little tool to make it even easier within our Jupyter Hub environment. And also everything we do is like using open data formats and open source programs. So also the interoperable bit of FAIR is well taken care of. And it's not only reusable, also we want reproducible. So actually users are also able to submit back their notebooks, and we really want to encourage our users to do so, submit back notebooks to our archive. So that if you actually have a certain result, that it is actually, you've submitted to our archive and you can actually cite that notebook in your paper so that others can actually just verify your results. And I think this verification of results is something that is really important in the future. This is kind of a schematic overview how of the service. I won't go into it too deeply, but do I have a little thingy point? Ah, yeah, of course. So I won't go into the authentication bit, but when a user authenticates with our service and basically a fresh, well, no, not already has happened, a fresh new Jupyter Lab service will, single user Jupyter Lab notebook server will be spun up for them. That notebook server is connected to some persistent storage so that when the user comes back, the data is still there. It's access to a database of notebooks, so we made sure that there's for every experiment in Jive Archive there's at least a rudimentary notebook so you can start working on. And data discovery is actually through our EVN VO service. And so, like I said, this really builds on the results from on work packages 3 and 4. So the single-user Jupyter Lab server is actually not just Jupyter Lab, but it's actually the Docker image we produce for Work Package 3. So that contains Jupyter Lab, but also Casa, and basically all the tools necessary to process an experiment from our archive. And of course, the EVN service was also already discussed in Mark's talk earlier. So the data discovery is through, we actually made, for that to make that a little bit more easy, we actually made a Jupyter Lab plugin. It's actually shown here. So this lab plugin actually just directly talks to the EVN VO service. So actually, if you want, you can still do everything manually, but this gives you a nice web form where users can submit queries. So here I show an example of a so-called cone search. So basically what you do is you say, for a certain position on the sky, give me all the sources within a certain radius, and I chose 60 arc seconds and 1 arc minute. And in this case, there were like 4 sources within that radius, and for each of these you get the experiment, an experiment name, a source name, the coordinates, but also the number of seconds that actually spent on source. So you can select an experiment where the time on source was sufficient for you to do your science. And like I said, for every data set, we already have a Jupyter notebook in our database. So if the user actually clicks on one of these experiments, he actually gets a notebook. The notebook will be opened with basically direct link to this data, and as the user press run, then basically our basic pipeline is run for that source. And so all the data processing is done using the Docker image we created in Work Package 3. So that, and all of that is based on Casa, as Des has already described. It's actually really de facto, in our field, the most common piece of software nowadays. It contains, oh, can I go back? Yeah, I can. It contains the latest version of Casa. We also created a kernel for Casa, because Casa, while actually Casa has Python bindings, actually, to get actually your results into a notebook, that actually requires a little bit more extra code. And that is actually taken care of by, oh, sorry. This is difficult, man. Come on. This is taken care of by a Jupyter kernel that embeds all your results in the notebook. Of course, there's the VLBI tools also developed by Des and Mark. And on top of that, actually, we also included quite a wide selection of radio astronomy packages. That's basically everything you may need. So basically a Swiss Army knife of packages. So yeah, I hope you are curious enough to actually maybe visit. Oh, what happened to the colors? They were white on my screen. So Jupyter Jive, jupyterhub.jive.eu. Thank you for your attention.
Thank you, Ard, and thank you to all the speakers. So in the last couple of minutes before we have time for some questions, I wanted to talk a little bit about what happens next. So I'm not going to try and go through the history of Work Package 5. This slide will be available online if you really want to read through the timeline. I am, however, going to break the rule I said at the start. I'm not going to try and give elaborate thanks to everybody, but I do want to make a call out. Some of you will remember Zheng Meyer, who was here at the start of ESCAPE. Sadly, she's not been able to work on this for the last couple of years, but really set the technical direction and the vision for ESAP in motion. So huge credit and thanks to her from where we've got to. But what I really want you to take away from this is that after we developed that vision and came up with the real plan of where we wanted to go, it feels like this arrow is getting wider and wider. It's becoming from a trickle to a stream to a torrent of different people getting involved, different ideas for where we want to take ESAP next. And I think you've just heard from all of our speakers about what the current and future research infrastructures are planning and how they see tools like this fitting into their own systems. So just off the top of our heads, I think there's a bunch of different ways that we can push ESAP from here. I think there are a whole bunch of technical improvements, sort of modest but necessary improvements we can make to the current code base. I would really like to push on support for provenance and persistent identifiers for the work that people is doing, better ways that people can share and collaborate on workflows. I would love us to think more in terms of virtual observatory standards and how we describe the relationships between data products and kind of a more rich semantics for doing that. But also we're now, I think, at the stage, and I think we've heard from the speakers that we're at the stage that this is now a sustainable project in the sense that it's no longer us kicking around some ideas for what we might develop and trying to build up enough momentum behind it, but we're now providing tools that people can actually find useful in the real world. And I think that's really exciting as we move forward and as we're talking about the continuing ESCAPE collaboration over the next few years, seeing this become an almost self-sustainable project that the users are motivated to drive this forward, regardless of kind of the central direction coming from ESCAPE. I think that's really exciting. I also think that we then have opportunities to be a little bit more ambitious, perhaps, in the way we think about linking up some of these science platforms together. So the platform vision that we've exposed to date has been a sort of a bunch of different separate research infrastructure specific platforms. But an obvious extension of that is saying, what happens if you start linking these platforms together? You have a federated network of science platforms rather than just a bunch of sort of little islands. And I think that's a really exciting direction we can start pushing in. And in the course of the ESCAPE project to date, we've actually been able to make some sort of tentative steps in that direction. So I've included a reference here to the IVOA execution planner, which really neatly brings together some of the work in Work Package 5 on science platforms and how we would think about scheduling and executing some of these analysis tasks with virtual observatory work in Work Package 4, proposing this as an IVOA standard, that not just this is how ESAP does it, but this is how we can build open standards for how these kind of systems can interoperate, which I think is a really exciting way forward. On that note, I think I am out of slides, but we still have a few minutes for questions before we go to coffee.
Yes, we have Rosie and then Isabel. No? Yes.
Hey, yeah, so I have a question, I think, for Ard, actually, to start with. So you mentioned something really nice about the notebooks. When you went into the archive, you said you can select a data product in the archive and it will go to the notebook that's appropriate to run that data product. Could you say a bit more about how you did that?
So to go to the notebook. So you mean how?
I'm wondering how you link, presumably you didn't sit down and by hand, work out what the notebook parameters would have to be that matched each object in the archive. I'm hoping there's some IVOA magic involved, but I don't know. So.
Yeah, so I just I take basically a basic pipeline, and indeed from basically do a search and replace. I just have a little spots where you have to insert source name, you have to insert file names, etc. And to be perfectly honest, this of course is not actually optimal to do it like that. I mean, you have to. The nature of VLBI data is actually the schedules are quite complicated in the sense that it's all phase reference. So basically, you look at a certain source in the sky, you use for your calibration, and then you have a target, and you use the calibration from a brighter source and apply it to a weaker source. So it's actually the basic pipeline. Is usually insufficient. But so there is just some simple logic, just search and replace.
Okay, it sounds like future work maybe to use the metadata that would describe the data product as a way of filling in all of your parameters.
Well, that would, if you have sufficient metadata to also say, okay, this is my phase reference source. That would already be that would be fantastic. So these are my phase reference sources. These are my targets. And for the VLBI use case, actually, that would already. And of course, it can be much more complicated even than this. But for most use cases, that would already be a lot.
Thanks.
Yeah, so mine is a practical question, so maybe mostly for Ard again, but also for anybody thinking about doing this stuff. So when you're allowing general users to come in and use your systems to run notebooks and doing CASA type stuff, you're using non-negligible resources. If you want persistent file spaces for users, you're using non-negligible resources again. How in practice are you managing that at the moment? What's persistent? How much, how do you control, CPU use? And how is that then exposed to the user through the science platform?
Well, we do not control CPU usage. That is, so the number of simultaneous users are just not big enough for this to have a.
Which is now because everybody's logging into it as we speak. It's like 20 people are doing it right now.
Should have thought about that one. Yeah, but indeed, the storage thing, we are still not out of storage. So we basically looked at how much data do we produce, and can we basically fit. So EVN is done in sessions, right? We do every 3 months we do a session. 3 weeks, and then basically so we can we do 1.5 of those sessions? Can we store that on a machine? That is kind of that's where we dimensioned it at. So actually we haven't run out yet. So one of the things that so this is actually something we actually intend to actually work out as we go along. So how long do we allow users to keep the data? Because remember, the original data is in the archive, and the notebook contains all the steps. So in principle, the only cost for deleting the user's results, like the measurement, the big data sets, is just time, right? But we actually want to basically make a policy based on our experience. So we basically call it kind of a beta service at the moment. So we don't, and we make it up as we go along, basically. But yeah, this is something we have thought about.
Thanks.
Other questions? Right up at the back.
So this is probably out of my limited understanding of things, but I tend to think to Jupyter notebooks as a linear sequence of blocks. You do things in a sequence. But data processing is not necessarily like that. We have bells and whistles and forks and loops and all sorts of things like that. So am I right in thinking that Jupyter is linear? And if so, how do you accommodate for the needs for more complicated processing scenarios with Jupyter notebooks? Thanks.
So I can take a crack at that, and maybe some of the panelists will also want to weigh in. But there's two things. So first of all, I take your point about Jupyter notebooks. Of course, one of the common criticisms of Jupyter notebooks is they're annoyingly not linear, because you can start executing blocks out of order and really confuse yourself. But nevertheless, I take the basic point. But I think this loops back to some of the work that we've seen, in particular shown by the CTAO folks. I mean, we are not targeting ESAP and a science platform as a Jupyter notebook engine, but as a general method of bringing together all sorts of different services. And so for complicated workflows, CTAO is pushing forward with Dirac. Potentially, I would imagine, I don't think the SKAO world has really formed a full vision about this yet, but I would imagine that they would also have a complicated workflow solution in parallel with whatever happens with notebooks or similar technologies. Is that a fair summary?
Yeah, so one thing, I fully agree with you that workflows can be much more complicated, and especially the core data flows that do the processing from raw data to science-ready data, because it might include creation of training samples based on the data that is then further used in the later data processing steps. So even parallelizing certain processing of data chunks, and bring them back together These more complex workflows are, I think, currently understood or in implementation using the direct processing, batch processing system, where certain job worker nodes are being developed that are then spawned from that could be potentially spawned by the ESAP that also has an asynchronous worker node. Yeah, so they could align and synchronize these workflows. Now, the interesting question would be how to get these more complex workflows in a Jupyter Notebook interactive environment where also the user can interact with the workflows. And I don't have an answer, but certainly persistency of the notebooks and certain steps would be a key element to have to explore these kind of more complex workflows, right? Where users then start a certain workflow, then come back later once notified a certain step has been accomplished, and then starts from the step in the notebook where they have left off. Yeah. But this is a topic for future investigations. Yeah.
I was just going to quickly add, if I can, as well. So notebook environments are not just for executing Jupyter notebooks. I mean, they're just general compute resources. So you can also run scripts depending on the software that's available within that environment. And this is what Binder does in terms of installing software. But I was just going to mention as well, I mean, there are tools like Dask, which can provision ephemeral compute clusters, so the user can take advantage of some slight, an abstraction of Python objects, for example, and then deploy their workloads across a larger compute cluster simultaneously from within a notebook or a script, which is sat in a smaller compute environment on a Jupyter Hub service, for instance. But it'll require the user to sort of understand how to take advantage of those kind of tools to maximally use the available resources.
Okay,
Thanks,
so we've come up to the hour.
Great.
Can we give a round of applause to John and James Matthias, please? And with that, we do have we have the last coffee break for the afternoon, so please swiftly grab yourself a coffee or tea and then come back, because we do start back at 15:40, and we do have online speakers in the next presentation, which will be chaired by Stephen Sajjan. Thank you very much.
Relax. Remain calm. Just without attempting to be involved with the physical
gets phonetic. The mouth gets kinetically energetic, as simple as your alphabetics. My words you all can never mock, long as my name is Ben Jones Jacques. I keep you open like your pupils in the dark. Dogs bark at the gate, syndicate what I create. Still I write rhymes, regardless of the stop signs. In tough times and nice times, for shade over sunshine. Throughout time, all times have been the right time to recite mine to mankind. Who wants mine? Come get mine. You best combine mine before you cross that fine line and say who's so called inclined. Press rewind. You're fine if you're blind. You can't see how this defines and redefines them. USIC, who I be, HIP, HOP. You know we, as them strangers, there's some wish they could be or not to be. And possibly, as it transcends from the pen to the key to the mind, you will find an MC good enough to envy. As long as I'm alive, it'll send me to that next shit that some just can't get with or F with. Since my alma mater told you that it don't quit, kid. It don't start until it all seems to be so. Stop to hip-hop. If it don't stop till I stop, and I don't stop till it stop. Big MCs and so props like rag mops must get dropped. Rising to the top of the bottom, but how I got them. If your heart's glass ceiling is my mind's glass floor, whose style do you suppose reaches higher plateaus? While you kick them, sell out blows and hope to sell out shows. But get your spots cooking easy as the wind blows. Jay remains reppin', all the heads hold steppin'. Whose style shall be the illest, with or without the weapon? With or without a doubt, I maintain with just the facts. Improving skills with or without the record contracts. And yet still, if that be's the case, my presence was a gift in its own right. So I remain strong, long ass, hands clap on, snare drums tap on. Jay's words stay born, and cornballs who rap on get snapped on. Live lyrics will be just that, just fat, just right. For all of those who feel the flavor's tight, I'm dedicated to the flow. The only way the true lyricist could ever make it seem so damn renovate the raw shack with lyrical scaffolds, head to baffle. There's tracks to travel, you unravel, or should I say unwrapped in this world where mics get checked in, all cornballs get slapped, all right rhymes get rewritten, no bullshitting, perfected. JL runs point and stays on it. Mastered styles look back and laugh at first drafts. Freestyles make foes wanna pay down on it. Do anything but lay down on it. Anesthesiatics get trapped like rats and addicts to craft addicts, but then transform like skill wax to insomniacs with my name in your almanacs. In fact, I let my glory be the never-ending story, like those that still inspire since 7 albums before me. Cause yo, from this old school comes a new degree, yet to be mastered till longevity seems to be that. You make it seem so.
2 back-to-backs before the end of the day. Thank you so much. How you doing, Ian?
I'm fine. No idea how I'm going to get through all the questions that you
Only if they open it up.
Okay. So we have with the 2 back-to-backs, and you can see the names behind. We have Stephen Sargent. This session is Citizen Science to Enhance Scientific Research. Stephen's an Open University Professor of Astronomy, and he leads the Engagement Communication Work Package of ESCAPE. And I'm going to pass the floor directly, as we have also people online as speakers, which is wonderful. And I do also want to highlight that we have, in fact, about 40 people listening in remotely, which is absolutely great. So thank you those remotely, thank you those in the audience. And with that, I'll pass the floor to Stephen. Thank you.
Thank you very much. I was just feeling jealous of all of the opening slides of all the other talks, that everyone had put beautiful photographs up, and I hadn't done it, but I'm really pleased that the other engagement and communication work package people from Trust IT have managed to do this. So thank you very much, Trust IT. Who are the other partners who are doing the stuff that is not directly citizen science related as well? They focus also on that in ESCAPE. So, I'm going to talk about the ESCAPE Citizen Science to Enhance Scientific Research. Let's see if I can make this thing work. Big green button, apparently, wasn't it? Yes, here we go. So, I'm speaking for the people in the work package, Rita, James, Hugh, Luigi, and Maud, as well as the wider group who you'll be hearing from soon. So this is where we fit in to the provision of services generally in ESCAPE. This is a picture that you've seen now several times today. We are up there in citizen science. And what we do in citizen science is it's fundamentally a data mining tool. So from a scientist's perspective, it is there for doing experiments for you. It's a data mining tool. And humans approach data with capabilities that machine learning simply does not have. Humans can take a step back and sort of unask the question, and do things that are maybe difficult to express simply and algorithmically. So, for example, imagine that you are you're wanting to recognize faces in a crowd, okay, and you've got one of many off-the-shelf algorithms for facial recognition. And so here's your data. I should say, by the way, apologies to those of you who have seen some of these slides before, but in case that there are people who haven't, I'll just run very quickly through our vision for what ESCAPE should be doing. So let's say you want to do facial recognition, and here's the data. And of course, right, the machine, you can see the machine is just going to go face, 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 but the human is going to take a step back and say, wait a minute, there's a clown in the middle of the data set. So humans can have a perspective that is something that's much more, that's really quite intractable for machine learning at present. So our vision is this: you'll have data that exists in the data lake and science platforms interacting with it. And from those science platforms, you create and manage citizen science projects, and the volunteers then, the engaged volunteers, can then come out of the citizen science projects and into the more accessible of our tools, so for example, the virtual observatory tools, and then you could imagine the most engaged volunteers, a small subset, coming out and then getting into the nitty-gritty of the data analysis themselves. So this is very much schematically how we see citizen science fitting in. So this was how we set it out at the beginning of the project, and the aspiration was to open the, I won't read this all out, I will just say that our aspiration was to open the science-related ESFRIs to the general public by creating, managing these citizen science experiments. And fundamentally, the public are the people who pay for this, so they really, really should be seeing some benefit from the project. We are creating legacy resources for notebooks. Again, I won't read this out. It exists here in the slide, so it will exist on the conference website in the end. So it's there as documentation. But you will be seeing some of these notebooks running later in one of the other talks. So we see very much our vision is to have experts interacting with the European Open Science Cloud through all sorts of means that we've been hearing about, but fundamentally the experts are leading the way for the science-inclined public. So we will be hearing from several citizen science projects in this session. The first will be from KM3Net. Now, I'm cheating slightly. This was a project the Citizen Science Project was created through the aegis of the Reinforce project rather than the ESCAPE project, but it is a project where ESCAPE Citizen Science played an advisory role, so we do have some staking in it. We'll also hear from Martin on the Pathfinder LOFAR, the SKA Pathfinder LOFAR on the Radio Galaxy Zoo project. And then we'll focus on precursor facilities to the Vera Rubin LSST, which of course doesn't have any data yet, but precursor data does exist on the Subaru Hypersu Prime Cam data with a brand new project that has just launched a day or two ago. The SuperWasp Black Hole Hunters project and Galaxy Zoo Clump Scout. And then we'll go through some exemplars of running citizen science from ESAP. And I will just say very, very quickly that we are also trying to expand our citizen engagement in the European Open Science Cloud to other projects, to other domains, so social sciences and environmental sciences. So we have a project characterizing knitting patterns in domestic magazines and another project on resilient food systems in sub-Saharan Africa. The latter one is getting humans to characterize a very heterogeneous data set which will be of use for food supply and food security. And the Knitting Patterns project is getting humans to look at a lot of complex data. I mean, you could do character recognition on this, but really you want to know who is this aimed at? Is it a pattern for a child? Is it a pattern for an adult? What sort of materials? Are they expensive materials? Is it a complex pattern? And so on. And all these things are useful for social scientists and historians. And so with that, I will just say thank you very much to everyone who has worked on this project. It's been very, very interesting so far. And I think I now hand over to Gwen Hale, whose name I have almost certainly mispronounced. I'm terribly sorry.
So I would be happy to go with Gwen. Thanks a lot, Stephen.
Gwen, okay.
I'm going to turn on my camera so everyone can see me, maybe. Hello, everyone. Sorry I cannot be with you in Brussels today, which is kind of a shame because I am actually working in Belgium, but wasn't not able to be with you this week. Do you see my slides?
Not
I'm not
yet.
sure you...
They're just...
I'm sharing my screen. No. Yeah, okay, perfect. Thanks a lot. As it was already said, so I'm Gwenaëlle de Wassage. I'm a professor at UC Louvain in Belgium, and I will be talking about the Deep Sea Explorer project, which was part of the EU SWAF project Reinforce. That is also coming to an end as ESCAPE. So congratulations to everyone for a wonderful ESCAPE project. And I'm a member of the KM3Net collaboration. So just a very quick word about KM3Net, because I believe that most of you in the room know this SFRI very well. So CAN3 is a neutrino telescope that is currently being deployed at the bottom of the Mediterranean Sea on 2 different sites, one offshore Toulon in France and one near Sicily in Italy. And you see here a sketch of what the experiment would look like once completed. So we're talking about lines that are anchored at the bottom of the sea, and at all 18 spheres containing each one of them 31 PMTs, photomultipliers. And so these PMTs will be sensitive to the Cherenkov light that is going to be emitted as a consequence of the interaction of a neutrino with the surrounding water. I'm not going to go much into details because actually what we were searching for in reinforce was what was not a neutrino. And so you see here the 2 different workflows that we've developed through the project. So the first one targets bioluminescence. Of course, when you put PMTs at the bottom of the sea, you can detect Cherenkov light from neutrino interactions, but you can also detect any kind of light. And especially the one coming from bioluminescent species that are populating the bottom of the sea. And so what we did was to extract light curves from CAN3net data and ask the citizen scientists to classify these light curves. And then the second workflow was using acoustics data. So in CAN3net, we're using hydrophones to calibrate the detector, to do positioning in the detector. But again, because you have hydrophones at the bottom of the sea, you can hear anything that is passing by a detector, and especially sea mammals. And so the second workflow was proposing to the citizen scientists to classify some spectrographs. So here is a view, if I manage, here is a view of the 2 different workflows as seen in Zooniverse. So again, on the left side, you see the bioluminescence and an example of the light curves that we are providing to the citizen scientists to work with. So the rate as function of the time. And so the 4 different classification were 1 peak, 2 peaks, multiple peaks, and weird. My very naive opinion would be that this is multiple peaks. And then on the right side, you see the same, but for the bioacoustic workflow now. And so in this case, so we were showing the spectra on the right and then the spectrogram. And so you see here, the 4 different categories were sperm whale, short fin pilot whale, pure noise, or something else, meaning potentially another sea mammals. And so in this case, I would myself go with the sperm whale as for example. So just a few quick facts to give you a feeling of how our demonstrator in Zooniverse was evolving along the years. So we went for the beta testing in Zooniverse between August 2021 and September 2021, and we got very useful comments. Very quick, because I don't have a lot of time, but just to give you a feeling of how precious can be the help of these beta testers, the first name of the project was Deep Sea Hunters, because we say, like in our community, that we are neutrino hunters. But because it was associated to deep sea, we had a lot of comments saying, no, but you're not hunting sea mammals. This has a really bad impact on how people will see your project, so you should change the name. So we moved from deep sea hunters to deep sea explorers. So this is something we as a scientific community could not feel harmful, but it was actually for the Zooniverse community. Due to some internal change in the work package team, the official launch only happened in January 2022. But a month after this launch, we had more than 50,000 classifications from 752 classifiers, and the project was actually 100% complete. So we were at a point where we said, okay, let's analyze the first result of this, what we call then phase 1, and see if there is a need to put new events. And I'm going to show you the results, and you will see that indeed there was a need for a phase 2, but we did motivate that to the citizen scientists. So we show them the preliminary results of phase 1, and then we said, look, we need more information, so we are going to launch a phase 2. So phase 2 is still running now, but because we are an EU project also arriving to its end, the last deliverable was submitted in July, and we could demonstrate in a quantitative way the impact of citizen science on Chem3net data classification. And I'm also going to show that very quickly. So results of phase 1, I'm focusing here on the bioluminescence workflow, so the one that was on the left side of my slides. And so while some events were clearly classified in only one of the 4 categories, like this one, for example, that was classified as a 2-peak, others were not. So the participants could not unanimously put them in only one category. And so you see here, the 50 events after phase 1 that were preferentially classified as 1 peak or as multiple peak on the right. But you see that while for the left hand side of the plot each time, it's kind of like clear it was made, the main classification was over 90% of the classification. It's not the case on the right hand side of the plot where there are several classification that competes. So this motivated the fact to go to a phase 2 to increase the fraction of events that were classified as the one on the left-hand side of the plot. And then after phase 2, so these results are coming from the analysis of the classification from the citizen scientists in July. So you see here, it's for bioacoustics. And so the way we picked the event to be classified were selecting the events that pass our CNN with less than 70% of accuracy. So the events that were poorly classified by our CNN. We gave them to the universe to be classified. And then if at least 2 different participants classified them and that there was an overall accuracy of at least 65% for the event, it was used to retrain the CNN. And doing so, we managed to reach accuracies of 90% and 100% for sperm whale and short fin whale, respectively. And so you see here kind of a before-after we prepared for the citizen scientists. And so there is a clear impact of the use of the classification done by the citizen scientists in training the CNN compared to before doing so. And so that's it. So I would say, as a conclusion, join us, both in the project if you're interested to play with Chem3net data, but also in doing citizen science, because there is really a big plus for every scientific project, I would say. Thanks a lot.
Thank you very much, Gwen. And I think our next speaker is Martin.
May I get my slides back? Day 1 is over. Can all go home. Cocktails. Okay, here we go. Right. Great. Okay. So yes, I've been asked to talk about Radio Galaxy Zoo LOFAR, which is a SKA precursor project, and this is a kind of genuine ESCAPE project in the sense that we got quite a lot of support from Hugh in particular, who's going to be talking later, to get set up on the Zooniverse. So I don't really need to do much of a LOFAR introduction because Jan already put up like almost exactly the same images. So for those of you who are asleep in Jan's talk, just to remind you, LOFAR is a large area radio telescope spread across Western Europe and is an SKA precursor in terms of its volumes of data and the sorts of things, the sorts of science it can do. What I'm actually going to be talking about is data derived from the Dutch baselines of LOFAR, so zoom right in to the eastern bit of the Netherlands to think about what we're looking at next. So what we're doing with LOFAR in a project called LOTS, the LOFAR 2-meter sky survey, which has been mentioned a couple of times already today, is to survey the northern sky, ideally all of it with LOFAR. So each of these dots that you can see here, the green dots, represent an 8-hour observation with LOFAR that we've made
and processed. Anything that's in green there has been processed already. A subset of that forms our second data release, which is out now, has been out since earlier this year. So LOTS, for the radio astronomers in the audience, LOTS is the largest radio survey ever done by numbers of sources. There's 4.5 million sources in here. It will be beaten by SK and maybe some of the precursors if they get their act together. But right now we're the biggest, and it is much more sensitive than any other radio survey that's out there. About 10 times more sensitive than FIRST for the same sort of resolution. So LOTS is great, lots of sources, but one thing about the design of LOFAR is that it actually gives us a view of the sky that we've not had before. So now I'm cheating slightly here, because this is the middle of the Coma cluster, so for radio astronomers will know that this is there's quite a lot going on in this bit of sky, but this gives you an idea of the complexity of the radio sky that we see. If you've seen the output of radio surveys before, you will have thought of them perhaps as having a lot of little dots in and not much else. But because of the design of LOFAR, we're sensitive to both small scale and large scale emission, so we see both compact sources and extended sources. And it's this complexity of the radio sky that is actually our problem for a citizen science project, or for generally interpreting the data, because if you just have a bunch of dots, your task is quite easy. If you have stuff like this on the sky, you've got to work harder. So the basic problem that we're trying to solve, or the two problems that we're trying to solve, are the association problem and the optical ID problem, and we try to solve them both together. So what you've got here on this montage is some examples, first of all, of individual sources detected by the source finding algorithm that we apply first of all to the sky. So you can see the coloured images are examples of the sorts of things we see in a pure radio image. And you can see also on top of these the ellipses indicate sources that we have detected by running source finding on the whole sky. So you'll notice that some of these sources are not actually one ellipse, they're two ellipses, or three ellipses, or several ellipses joined together. You can see that these are all the same physical object, but the source finding algorithm can't. So we think the sky is broken up into discrete Gaussian chunks, and you guys can all look at this and say, oh yeah, that's one object. I think you probably can anyway, but the computer can't. And then secondly, what we really need to do with radio sources is to say, what is the optical source that corresponds to this object in the radio sky? The saying is that there's nothing so useless as a radio source. And the reason that radio sources are useless in themselves is that you don't have a redshift, so you don't know what that radio source is. It could be right next to us, or it could be at the far reaches of the observable universe, and we've got no clue without some extra information. So you can see, I can find the right button, you can see that we're now, in some of these other pictures, we're seeing the optical sky. This is from the legacy survey, the DESI legacy survey, I should say, because now there are two legacy surveys. And you can see that underneath the radio contours, we can see optical galaxies belonging to some of these objects. And so that process we call identification is, you say, okay, look, I found that radio source, it belongs to that galaxy. Then we can go forward and do science with it. Okay. All right, so those two problems taken together, involving analysing very complex images, motivate citizen science. And we weren't the first to think of this. The original Radio Galaxy Zoo was a project that worked on FIRST data, so a VLA survey similar to ours, but with less sensitivity to extended emission. They used a modified version of the Zooniverse platform, and they were quite successful in getting optical IDs of a number of FIRST objects, although sadly the final data paper for Radio Galaxy Zoo hasn't come out yet, but there are a bunch of papers on this that you can look up. So we decided essentially what we would do is to borrow this for our Radio Galaxy Zoo LOFAR. We set this up, I guess it must have been at the same time that ESCAPE was being set up, and at that point Zooniverse had just transitioned over to this Panoptes platform, and so we were able to get some valuable support in using that to set up our project. And what we did was we pulled out objects that we knew from the catalogue were big and complex and sent them off to viewing by citizen scientists. So this is an example. You can see the sort of thing going on here. This is the source of interest. It's the thing in the middle of the screen with the solid ellipse around it. But it's composed of several components, which you can see here. There's also an unrelated source over here, which has got its own optical ID. Now, again, with very little training, a human can look at that and say, I believe these components go together, and that's the optical ID, the big galaxy in the middle, and this is unrelated. But this is a quite difficult task for a machine, particularly combining the two wavelengths. So we make these views of these objects. We generate these algorithmically, so they're static views. You're just looking at a set of PNGs. The DESI Legacy Survey gives us the optical data, which allows us to give a nice sort of colored view of the sky that users can interact with. And we say, tell us which radio components go together, tell us which is the optical source that goes with them, and tell us if there are any problems with the data. And we let that run. So I think this ran for about 2.5 years, can that be right? Seems less long, but most things do. 11,000 volunteers, about just short of 900,000 classifications. We asked them to inspect 175,000 objects, and we got about 46,000 optical IDs back. And the fact that that's quite a low fraction is an interesting part of the problem here. All of this is going to go into the main optical IDs paper, where most of the optical IDs that we'll be doing will be purely algorithmic based on maximum likelihood, because most of our sources are compact and we can do that. But it's an input into this optical ID page, which will have about 3.5 million optical IDs for radio sources, which is more orders of magnitude than you can count, more than we've previously had. And this enables a vast range of science, so all sorts of things are going to come out of this. I think it's worth highlighting the issues with this. The first one is how long it takes, and actually the plot that I'm showing here illustrates partly why it takes so long. So this is a plot of the log of number of classifications completed against the number of views, number of users, I should say. So I shouldn't say views, sorry, number of users. So the largest number of people of all come in, they do one classification, they go away again. And that's essentially noise, because they haven't had time to learn anything in the process of doing it. So we're not really gaining very much from those people, unfortunately. On the other hand, we have a scarily large number of people who stayed with the project all the way through and did hundreds of thousands of classifications. One of those was me, but because I wanted to get it finished. But there were some genuine citizen scientists over here as well. And you can see the sort of vaguely power law distribution here. So you are going to get most of your classifications from a fairly small number of people. You can also see some of the mistakes that the citizen scientists make. A very common one is not to pick the right optical ID, because there will be some source that's bright in the optical that just, so there's a bright optical source here, but actually the real ID is in the middle here. It's an infrared source. You can't see it in the optical. The citizen scientists go for this because it's a bright object. We get offsets between the real ID, which you can see here, and so on. And sometimes we just get obviously complete despair from the citizen scientists, presumably. The optical ID is just slapped in the middle of this because nobody knew what this object was. And in fact, the image we gave them was much too small. And this is a really big radio galaxy that goes off through the ceiling and down through the floor. So you can't blame them, but that's just a limitation of the setup. But I think it's also really important to highlight the value that we get out of it. So individual thought gets put into the most interesting objects. There are pages and pages of discussion of things that are found in the low-far sky. We get tags and comments and so on that allow us to flag these things up for science follow-up, and that's happening. You get dialogue between the citizen scientists and the researchers, and that's really important. And you can go off and say, do we know if we're seeing this class of object in real time in the data, and people can look for it. So this is an example of somebody's MSc project being done through the platform. Okay, so where next? Final slide. I think this is as big as I would want to do for a citizen science project by some way. It's probably bigger. There And there are real issues for us with selecting the right objects and asking the right questions. And I think one of the things that we find is that this is just too hard a problem for a lot of people to be able to spend the time on. At the same time, there's a clear role for citizen scientists in answering the most complex questions, dealing with the most complex objects. And I think one of the things we need to do, we started doing this, but we need to do a lot more of it is to use machine learning to help us select what should go to the citizen scientists in the first place, as we heard in Gwen's talk. If you imagine what's coming next in this domain, we're going to carry on doing our All Sky survey, but SKA and LSST present a much, much larger problem when the All Sky surveys with SKA come along and they're being matched up to the optical data. LSST will have a lot more to do. And I think a point that Stephen made at the start that I would like to reiterate is that you really need a really good interconnection between the citizen science platform and the science platforms, because I think a lot of what we would like to do was stymied by the fact that fundamentally we're just giving the citizen scientists static images that we pre-generated and saying go and do science with that. But there's a lot more we could do with the sort of platforms that are being set up for the SKA and other things to give them a better experience and to allow them to do more, and that would benefit everybody. So thanks for listening, and I will stop there.
Thanks very much. And I think we now move to some online talks. What could possibly go wrong? And I think the first will be James talking about our brand new citizen science project, Galaxy Zoo Cosmic Dawn.
I'll share my screen.
Brilliant.
And that should work.
Okay. Perfect.
Okay, great. So I'm James, and with the support of ESCAPE, I'm working with Hugh Dickinson and Stephen Sargent at the Open University on an LSST Vera Rubin precursor citizen science project called Galaxy Zoo Cosmic Dawn. So this forms the latest iteration of Galaxy Zoo, which is the longest running and most popular project on the Zooniverse citizen science platform. So I'll start with a quick overview of what sort of the purpose of Galaxy Zoo is. And this is based on the fact that the core aim of extragalactic astronomy is to study how galaxies form and evolve over cosmic time. So galaxies come in a variety of shapes, such as the images you see here, from ball-like ellipticals to those with grand spiral arms. So to study their evolution requires a large number of classified galaxies. Citizen science helps play a crucial role in the examinations of such large data sets. So this is where we go to Zooniverse. So Zooniverse has been mentioned a few times now, so I'll quickly explain that Zooniverse is the world's largest and most popular platform for citizen science, made possible by volunteers, more than 1 million people from around the world who come together to assist professional researchers. Galaxy Zoo is one of these projects, and it asks volunteers to classify images of galaxies based on their visual appearance. And this gives the public the opportunity to contribute meaningfully to scientific discovery, while also helping to inspire the next generation of students and scientists in astronomy. So Galaxy Zoo has seen multiple iterations over its 15-year lifespan, with volunteers examining an image such as the one you see here, and answering several questions in Galaxy Zoo's decision tree, such as, is the galaxy smooth or featured? Are there any spiral arms? If so, how tightly wound are they, or how many there are? Is the galaxy merging with another galaxy in the image? Or are there any rare features such as gravitational lensing arcs? This new iteration, Galaxy Zoo Cosmic Dawn, is creating classifications of galaxies taken by the Hypersuprime Cam, HSC, on board the 8.2 meter Subaru telescope on the summit of Mauna Kea in Hawaii as part of the Hawaii 2.0 or H20 Cosmic Dawn survey. And there's a picture of the telescope on the right there. So the Cosmic Dawn survey is a large multi-wavelength survey covering 50 square degrees of some of the darkest fields on the sky, with a scientific aim to understand the coevolution of galaxies, their black holes, and the dark matter halos that host them over cosmic time. One facet of this is the H2O survey. This uses ultra-deep Subaru HSC imaging of the two primary Euclid deep calibration fields, which include the Euclid Deep Field North, or EDFN. This is aiming to push the boundaries of extragalactic astronomy by studying galaxy evolution out to high redshift of about redshift 7. And so the Galaxy Zoo project incorporating these images presents volunteers with hundreds of thousands of these H2O images of this 10 square degree Euclid Deep Field North. And this has multiple benefits. So firstly, as I mentioned right at the start, this is a precursor for LSST, Rubin, by providing multiband ground truth sets for use in training deep learning models with all these classified galaxies that we'll have. And this can be used for things like strong lens finding, for example. This project can also be a precursor for Euclid, as obviously we're looking at the Euclid Deep Field North, so we can provide initial classifications for rapid follow-up imaging of the most interesting objects. We're also using higher end resolution imaging over an intensely studied area, and combined with deep multiband imaging allows for studying both high redshift sources and investigating low surface brightness features. And of course, with the help of volunteers, we can try and spot any interesting objects, including those from serendipitous discovery. So the HSC data has been converted into these PNGs and been uploaded to Zooniverse using a new color scaling due to most of the sources having higher redshifts than is typical for Galaxy Zoo. They seem to be they're more further away. And the decision tree of questions has been updated for these images. So there's an extra question on clumpy features, which I won't go into details on because Hugh has a talk based around clumpy features in a moment. We're also expanding the star artifact option that Galaxy Zoo has by default. For anything that's not a galaxy, you can classify as a star or artifact. We've also added a bad image zoom option, which can be combined. And this option, combined with another improvement to the workflow, which is the ability to classify what type of artifact you encounter, will allow the H2O team to improve their pipeline, their modeling pipeline, so we can reduce the number of these non-galaxies that get presented to volunteers. This will help improve the volunteer experience. And we're also putting a greater emphasis on strong gravitational lenses due to their rarity and their importance if we find them at these higher redshifts. So after the project finishes, this will lead to a whole number of publications. So as well as a data release paper, there'll also be a paper on the detection of strong gravitational lenses that are found, any statistics on clumpy sources, and investigations into low surface brightness features that are found, as well as many others. But currently, the project has just launched. It's had its public launch only a few days ago, accompanied by a blog post by the H2O team. And as of today, I checked earlier, there are now over 30,000 classifications made by volunteers in just a few days. So please feel free to join in, and thank you for listening.
Wow. Thanks very much, James. And next we have Hugh.
Hello, bear with me 1 second while I try and sort myself out. Right, you should be able to see a screen.
Yep, thank you.
Perfect. Let me get a laser pointer. Well, thank you very much. So my first talk today, you've got 2 talks from me today, unlucky, is about SuperWASP Black Hole Hunter, which is a precursor citizen science project for the Vera Rubin LSST survey. As with all the other talks, I just want to highlight some of the other team apart from me. Adam McMaster is a PhD student here at the Open University, and there are various other people from the Open University in that list. So the idea of the SuperWASP Black Hole Hunters project is to search for hidden black holes in our own galaxy, in the Milky Way. Now, I realize that most of you in that room probably already know what a black hole is, but just in case, a black hole is the end state of the lifetime of particularly massive stars. So stars like the sun, they will live out their life and eventually end up as something called a white dwarf. But if you get a star that's substantially more massive than the sun, when it gets to the end of its life, it can no longer support its own mass, and its core will collapse down to basically a point of infinite density. And the gravitational field of that infinitely dense point is so strong that even light can't escape from it. So you have an object where if light gets close enough, it falls in and can never escape. The problem that we have is that you can make a simulation of the stars in the galaxy and how massive they are, and you can predict, therefore, how many of them should end their lives in this black hole state. And the prediction that you get is there should be a few 100,000 stellar mass black holes in our galaxy. Contrast that then with the amount that we've actually detected, which is around about 30. And the vast majority of those are in a very special type of system where they're actually orbiting another star closely enough that material can fall from that companion star onto the black hole and be accreted. And as it's accreted, it heats up and glows very brightly in X-rays. And then sometimes some of that material is actually ejected along the spin axis of the black hole in these relativistic jets. However, this project isn't about looking for that type of system. This project is about looking for black holes in another way, which is by the influence that their gravitational field has on light that passes close to it. So you probably know that Einstein predicted that gravity is actually a manifestation of the curvature of space-time. And that tells us that light, even though it has no mass, the trajectory of light rays passing close to a massive object will be deflected. And if the massive object is massive enough and dense enough, that actually results in a magnification effect. And we call this, well, gravitational microlensing. And so what this image is showing is that if I have a star and a black hole that I can't see passes in front of that star, the gravitational field of the black hole will actually magnify the light of the background star, and we see this very distinctive peak in the light curve, which is basically it's the plot of flux versus time from the star. And so we want to search for those distinctive signals in a particular data set, and the way we decided to do that was with the citizen science approach. The data that we wanted to use was from this telescope, which is called WASP, which stands for the Wide Angle Search for Planets. And each of these 8 things is actually just a telephoto lens that you could buy for a very expensive camera. But behind each of those is an astronomical grade CCD. And WASP actually is excellent because it surveyed a very large part of the sky for a very long time, for 8 years, with variable cadence, but down to inter-exposure steps of about 40 seconds. So it's really good for finding variability in stellar light curves. We took the data from that telescope and we made ourselves a citizen science project called SuperWASP Black Hole Hunters. If you want to, you can go and visit it via this link. It's currently paused while we analyze the data. So let me tell you what the volunteers were actually looking for in this project. They were looking for peaks like this. So you have this very distinctive symmetric peak in a very noisy light curve. The noise of the light curve actually makes it quite difficult to do this analysis automatically. So let me show you some more examples. They're not all so obvious. Some are more narrow, some are more shallow, and some are really hard to see at all. And of course, what I'm showing you here are actually simulations. These things are extremely rare. And in the real world, we don't have that nice gray bar telling us where to look. So what are the volunteers actually looking at? They're looking at things that look more like this, okay? So these are just noisy light curves, and we're asking them to find things that are peaks that are inconsistent with the overall noise level of the light curve. It's a tricky task. Here's a few more examples. Okay, so we had a massive response for this project. Basically, the trick is put the word black hole in a project and you will get a massive response. So we engaged 5,000, well, nearly 5,500 volunteers. Together, they have so far inspected over 200,000 light curves, and that comes to 2 million classifications, okay, in the space of about 6 months. To analyze the results, what we had to do was build a statistical model based on those simulated data. So we could use those simulated data to work out how good particular volunteers were at identifying real peaks, or what we expect real peaks to look like in the light curve. And then we can say, okay, volunteers up here in the top right, they're likely to get the answer right, whereas volunteers down here, they're less likely to get it right. So we'll weight these volunteers more strongly. And that allows us to find signals like this. Okay, so this looks a little bit like what we're looking for. Here's another one that looks a little bit like what we're looking for. Here's one that really looks like what we're looking for. However, this is where we say, well, we have to be very careful with these light curves, because if you actually go and investigate what this source is, it turns out that it's a particular type of variable star called a Mira that has a light curve that looks very similar to what we're looking for. And for that reason, once we've got all of these potential sources, we have to go through this very complicated vetting routine that was developed by Adam McMaster here at the Open University. I won't go through all the steps, but one important step is that we actually use tags from the talk forum that Martin showed earlier in the context of Radio Galaxy Zoo. So even if volunteers don't necessarily classify something, they can bring it to our attention via that forum, which has turned out to be really useful. Analysis is ongoing, so do watch this space. And I just want to just finish this talk with a bonus, which is that Adam went and actually engaged with the volunteers face-to-face at the British Science Festival week in Leicester earlier this year. Thank you very much. I guess I should crack straight on because running a bit behind.
Thanks very much, Hugh. And I think we have another talk by Hugh, but I will just note to all the speakers that we have now officially 10 minutes left of our slot. So do please accelerate if you can.
Got it. Right. Okay. Let me share again. A very fast trip through Galaxy Zoo Clump Scout. Okay. Once again, there are the team. You can read these slides later. So what's this project all about? This project is about searching for these things called giant star-forming clumps. And the story of giant star-forming clumps probably starts with this image, which is a very famous image taken by the Hubble Space Telescope, where they pointed the Hubble Space Telescope at what looked like a blank region of the sky for weeks, basically. And it turned out that that blank region of the sky was full of galaxies, distant galaxies. Now, if any of you ever bother to think about galaxies, this is probably the image that you have in your mind, this nice spiral galaxy with star formation roughly evenly distributed throughout the spiral arms. But when we come and look at the Hubble Deep Field, or the Ultra Deep Field, and let's say we zoom in on this particular part that I've highlighted, we find these weird looking galaxies that don't look like those nice spirals. They have these clumps of star formation, these bright blue clumps. And these clumpy galaxies, they turn out to be very, very common in the early universe, in the distant universe. And I'm going to skip over this because we're running slow, but I just want to point out JWST also sees clumpy galaxies. So you might well ask the question, why are these clumpy galaxies important? Well, let me try and convince you why they're important. This is a very famous plot from galaxy formation. What it shows is how many stars are being formed in the universe as a function of either time, going backwards in time, or this other quantity that we call redshift. And what it's showing you is that at the time, let me just get my laser pointer again, laser pointer. At the time when the universe was forming most of its stars, there were a lot of clumpy galaxies, but now, closer to the present time, when the star formation rate has fallen off quite a lot, there are very few clumpy galaxies, okay? So that means that when the universe was forming most of its stars, a lot of the galaxies, roughly 60 or 70%, were clumpy galaxies. So if we don't understand this clumpy mode of star formation, we don't really understand how the majority of stars in the universe actually formed. We can also see that the fraction of clumpy galaxies falls off quite rapidly as we come closer to the present day. So this is now on the left-hand side, and this is a long time in the past on the right-hand side. And we've probed down to redshift about 0.7. And this seems like a very small gap, but it actually turns out it's about 7 billion years of cosmic evolution that we're not really probing properly. So what we wanted to do with this project was to find nearby clumpy galaxies, and we already know that we expect them to be rare. So in order to find a decent statistical sample of them, we need to scan a very large region of the sky. And in order to do that, you've got a few options. You can design an automatic algorithm. You can come up with some heuristic based on brightness thresholds or something like that. That will be very fast, but it will be inflexible. You have to define in advance what you think a clump's going to look like. And remember, we haven't really studied clumps at low redshift nearby. They might be different to these high redshift clumps. The second option is to use citizen science. This has the advantage that, as Stephen said right at the beginning, humans can think outside of the box. They're very flexible, but they tend to be slow, and slow is a relative term. Obviously, it's not as slow as one person doing it, but it's slower than a computer. And then finally, we're now in the age of deep learning, where you should be able, with appropriate training data, to combine the speed of a computer with the flexibility of humans. And maybe I'll talk about that a little bit later. But the primary thing that I'm going to talk about today is the citizen science approach. So we designed this project, Galaxy Zoo Clump Scout. Again, you can go and look at the project via this link. And what we asked volunteers to do was basically look at an image of a galaxy from the Sloan Digital Sky Survey and click on the locations of all the things that they thought might be giant star-forming clumps. So that's things that are slightly brighter, slightly bluer than the rest of the galaxy. We engaged 15,000 volunteers, and together they inspected and annotated the positions of the clumps in about 80,000 galaxies, which is great, right? But the problem, if you like, with citizen science is you have to contend with this first rule of citizen science, which is that not everyone reads the tutorial. And what that means is you tend to end up with slightly noisy data, and you need to come up with some way to deal with that. So let me give you an example of what I mean. Here's a galaxy. It's not super clumpy. If an expert looked at it, they might annotate these and say that these were clumps, okay? We would love the volunteers to give us these classifications so that we could just run a clustering algorithm, aggregate the results, and say, yes, we found all the clumps. Unfortunately, the classifications we get look more like this, okay? So volunteers tend to be a bit more optimistic than the experts would be, and they'll just annotate anything that looks vaguely blue. So we need to design a complicated algorithm that can take multiple redundant annotations of the same galaxy, identify which clumps should go together, which clicks should go together and represent real clumps, and at the same time identify which clumps are actually false positives and discard them as such. And so we designed an algorithm which was capable of processing 3.5 million volunteer clicks, in fact, slightly more than 3.5 million volunteer clicks. That algorithm is available online. We put it on GitHub, and the paper describing it has just come out this year. So that's how, with that algorithm, we can go from this to something which looks like this and identify not only that the galaxy is clumpy, but where the clumps in it actually are. So we identified about 35,000 clumpy galaxies containing around 100,000 potential clumps, and Nico Adams wrote a paper releasing our first clumpy galaxy catalog in SDSS, which you can see on that archive link. The science result that we found is that, perhaps somewhat as expected, the fraction of clumpy galaxies has dropped like a stone between redshift 0.7 and the present day. And so now we see that the fraction of clumpy galaxies is roughly around 3% or something like that. So they're very, very rare. If you take a look at the light gray curves, I hope you can see the light gray curves on your screen. They're basically horizontal. Those are the predictions of the minor merger fraction, which is basically, it's how the presence of small galaxies in the region of bigger galaxies should evolve with redshift, because that's one thing that clumps could be. They might just be small galaxies that have fallen into bigger galaxies. The other one, the orange lines, is showing the turbulent fraction of galaxies. So clumps might actually be formed in the galaxies as a result of turbulence in the gas, causing that gas to collapse and form stars in clumps. And what we can see from these initial results is that it seems much more likely that turbulence in galaxies has fallen off substantially since high redshift, and that's why clumpy galaxies are now so rare. just to remind you what we were looking at there, I can skip that one, skip on. So I said I'd talk a little bit about the deep learning approach, and I will rattle through this really quickly. Why would we want to use a deep learning approach? Well, as people have pointed out, there are many more surveys coming along, things like Euclid, things like the HyperSuPrimeCam survey that James talked about, and we'd like to be able to find clumps in those surveys as well. They're further away, they're deeper, we can find more interesting things. So if we can use our citizen science results to train a deep learning algorithm, that will then have the speed and the flexibility that we can use to survey a few million galaxies, or in the case of Euclid, potentially even a few billion galaxies to try and search for clumpy galaxies. We've given this a little bit of a test with just a generic off-the-shelf deep learning algorithm, and we found 4 times as many clumps as the volunteers did. All of these are data that the machine were not trained on. So these are all test data, unseen data, and we're finding clumps in these galaxies. I'm going to skip that slide. I'm going to skip that slide. I'm going to skip all of those. So let me summarize. Clump Scout engaged 15,000 volunteers, 80,000 galaxies surveyed. We found about 35,000 potential clumpy galaxies containing 100,000 clumps. There are 2 papers already out, reinforcing the fact that citizen science is a tool for doing science. The first catalogue has been released. We've trained a machine learning model. We've released our aggregation software, and we have our 3rd paper already in preparation. So once again, thank you very much for listening.
Now, we are hopelessly over schedule. I'm very sorry about this. James, do you have a very quick demonstration of one of our notebooks that you can show?
I can do. I'll share my slides.
Okay, because we are now 18 seconds left formally of our session.
Is that shared? Yeah. So basically, another thing we're working on is trying to improve the experience, not just for volunteers, but also for researchers in managing their Zooniverse projects. So we've created a series of tutorial notebooks using the science analysis platform, ESAP, where they're stored and managed. And so we've got a few notebooks here. So we've got an advanced project building tutorial, another tutorial on integrating machine learning into your Zooniverse project, another one on advanced aggregation and subject retirement using the Caesar backend engine that Zooniverse has, as well as a Zooniverse Muon Hunters example that shows you how to load your data from the ESAP shopping cart. So you can use that to analyze your data from your Zooniverse project. And as well as that, we've also got recorded walkthroughs of these tutorials, as well as some speech-to-text documentation of the recordings for greater accessibility, and they can be easily translated as well. And so, as I say, they're stored on the ESAP as ESAP workflows, and that can be searched for and then loaded using the compute facilities. And then they spin up a Binder notebook to present you with the Jupyter Lab interface so you can run the notebooks themselves. That's probably the quick overview.
Okay. All right. Well, thank you very much, James. And since we are now 1 minute 38 seconds beyond the end of this, perhaps we could just end with this slide, which is where I think we are going next for citizen science in EOSC. And I think with that, I will call it a day. Thank you very much, everybody.
Thank you so much, Stephen, and panelists. A round of applause again, also for our online speakers. Yeah. I thought you were going to go through that very quickly, no?
Well, do I dare?
just give the 2 top parts. It's unfair if you don't.
Right. So, I was wondering what is limiting the crowdsourced data mining. And I think people seeing stuff work will really help. So people seeing science results from the projects and people seeing something that they can pick up and adapt will really help. And we need to do that in our fields, but also expand into other disciplines as well. And so I think that's what would help the most.
Thanks, Stephen. So I'm not going to open the floor to speakers. So I'm going to ask Livia and Rita to do a massive turnaround on the top panel, and I'm going to invite Ian Bird, who's the technical coordinator of ESCAPE, thank you, and a senior scientist at LAP, who will be chairing the final session of the day with a wonderful set of esteemed panelists. So can I have Ian up and the panelists onto the top stage, please? And we'll do the water and the names now. Thank you very much. Or Ian, do you want to invite the panelists up?
Well, yeah, invite them up. I'll introduce them. They're already here anyway. So.
Great.
Somebody left their laptop from the previous time. I know, I think it's just charging, actually.
Hello there. Nice to meet you. How are you? Okay, Ian, over to you. Thank you.
Yeah, so what I'll do is I'll introduce the panel, and then I'll talk about how we will run the questions. So I hope you're in the same order as I have you on the list. So first of all, we have Christophe Arvisset from ESA. He's also a member of the ESCAPE Advisory Board. So he's head of data science and the archives division within the Science and Operations Department of ESA, Directorate of Science, and is at the European Space Astronomy Center in Spain, near Madrid. So this includes the Science Data Center, which hosts archives of more than 20 ESA space missions, various data science activities in that context, and responsible for the IT infrastructure and services and other cross-mission engineering activities to support science operations at ESA. He's played an active part in international data alliances, so the International Virtual Observatory Alliance, the International Planetary Data Alliance, and International Heliophysics Data Environment Alliance. He's chaired the IVOA 2014 to 16, and is currently chair of the Planetary Data Alliance. So I think I should move on to Antonio, who is a much shorter set of words. Yeah, just do the top line. Okay. All right. So Antonio is Deputy Director of Operations at SKAO. And despite the fact it doesn't say it here, I know he's been heavily involved in setting up the SKAO computing infrastructure, data infrastructure, and the whole science infrastructure. Next to him, we have Paco Coloma, who is Director of the JIVE, ERIC, and is also the Chair of the ERIC Forum. Federico Farini, who is Director of the CTA organization. And then we have Apostolia Caramali, who is head of the unit of the Research and Innovation Actors and Research Careers Unit at the Directorate General for Research and Innovation of the Commission. And right at the end, we have Martina Romaniello, who is head of ESO's Back-End Operations Department and chair of the ESCAPE General Assembly, the latest chair of the ESCAPE General Assembly. Okay, very good. So now I have a number of questions. We have an hour and a half or so. The questions have been provided in advance, so people should have provided their answers. Now I'll ask a different set of questions. So I'll ask questions to each of you, not necessarily in the order in which you're sitting. And they won't all be, the whole list of questions won't be all at once. And I do invite other panelists to comment, and also the audience to comment. I think it would be nice if we have a more open discussion. So let me start with Apostalia. So fundamental research is essential for ensuring the excellence and attractiveness and the edge, competitive edge of the R&I ecosystems. In physics, particularly in this case for the ESCAPE work program, we have combined fundamental research and technological innovation together. So the new ERA should leverage such excellence and capacity. So what are the main ERA action priorities in Horizon Europe that have recently been addressed? And sort of following on for that, where do you believe the ESCAPE partners should prioritize their efforts in the coming future? You can ask the other question in a minute.
Good afternoon, everybody. Would you like me to take all the questions?
If you prefer, yeah.
Oh, up to you. Just to know and organize myself. Good afternoon, everybody. Very pleased to be here with you, and I was very pleased to follow the previous inspiring discussion, actually. I think I will start by updating you where we stand with ERA, with the European Research Area and Innovation Policy, and speak a little bit about Horizon Europe, and then also what we expect from research infrastructures. There are two big trends in the policy context right now. One is the European Research Area, which concerns research policy, and the other one is the new European Innovation Agenda, which concerns innovation policy. Both are not new concepts. There have been many discussions in the past. We have celebrated 20 years of the European Research Area. So what is new? What is new in research policy, and then what is new in innovation policy? What is new is the fact that there is a renewed commitment to actually work together and try to work on joint actions. This is, I think, the true novelty. There was a big political decision last November at the Competitiveness Council with ministers accepting on a new toolbox, adopting a new toolbox that will allow us to do that. And the new toolbox consists of what we call the Pact for Research and Innovation, a new governance scheme, and then the ERA policy agenda. The Pact for Research and Innovation is the first opportunity that allows us to put in writing many things that we do by practice. For example, which are the values that we share in research? The fundamental aspects of, for example, freedom of scientific research, ethics and integrity, and other areas. Then, which are the areas where we accept to work together? We know that traditionally we worked in research infrastructures, this is reaffirmed, but many other areas are also there, including novelties, for example, synergies between research policy and industrial policy, or synergies with education policy, or with employment and social policy, for that matter, which concerns researchers very much. Another area is the approach to investments. We are all familiar with the 3% of GDP investment target. Now we have a more refined list of investment targets, but most importantly, we have a methodology to go with it, some methodology which concerns reform. So this is what it is in the Pact. And then in the governance, we have clarified the role of the Council, how member states intervene at ministerial level, at directors general level, and we have established this ERA forum that brings together member states, associated countries, but also stakeholders, and infrastructures are represented by PACO for the moment through the ERIC forum, and there is a rotation approach that allows to involve everybody around the table. So this is the governance, and then the ERA policy agenda includes now 20 actions for the next 2 to 3 years. There is a dedicated action on infrastructures, on research infrastructures, another one on technology infrastructures, by the way. And then there are many other actions which indirectly affect research infrastructures. For example, open science, reform of research assessment, research careers, the delivery of EOSC, the link to industrial policy, missions, partnerships, and so on. So these are the novelties in a nutshell with the European Research research area. And then on the new European innovation agenda, again, there has been a renewed attention on which are the big drivers for innovation and what can be done. And now the big driver for this new European innovation agenda is the deep tech revolution and what can be done to underpin deep tech and prepare the transitions of the future. And there, 5 flagship areas have been identified. And I would like to draw your attention especially on 2, one which concerns talents, and the other one which concerns ecosystems, how we can support regional, local development, and what is the role of infrastructures for that matter, and what is the broader socioeconomic impact of infrastructures, and what is the potential, but also how we can make this work around big flagship areas. So please follow up. There will be calls dedicated on important flagships for innovation ecosystems. The idea is to create what we call innovation valleys. For example, to promote hydrogen production, semiconductors, and so on, just to give some keywords. Others will emerge as well. So this is in a nutshell where we stand with research and innovation policy. And if I can say a few words about infrastructures, more in particular, the dedicated action that we have on infrastructures aims at improving the methodology of cooperation, European cooperation on infrastructures, and there are a number of areas that are addressed. First and foremost, how we organize the landscape analysis, which is the backbone for understanding what we have and where we want to go. Secondly, which are the evolving needs of access to infrastructures? We have a traditional approach to access, but what more can be factored in? Is it only about transnational access? Probably not. Is it only about scientific excellence? Probably not. Yes, very important, but probably not, and so on. Third element is the involvement of stakeholders, very important. We had the launch of the ESFRI Stakeholder Forum. Some of you participated in that event. We want to take it to a different dimension. So not only organize annual meetings with stakeholders, but have a structural involvement of stakeholders. For example, in the landscape analysis per domain, and this is a very concrete area where this cluster will have a say, I believe, in understanding what we have now, which are the gaps and needs of the future. In the landscape analysis, I know I'm being a bit long, but I hope it's useful for you. In the landscape analysis also, today we have a rather flat approach. We only address the layer of infrastructures. But which are the services, which are the technology needs, which are the evolution needs that we want in order to go towards, for example, shared standards, an international approach, and so on. These are questions that need to be discussed, and you will be solicited. We are working currently with ESFRI on concept papers that will allow to discuss and see how we can address the question. And very quickly, I believe towards the end of the year, beginning of next year, we will be reaching out to you on this. We are doing similar exercises with the ERICs, and I'm very thankful for the commitment of Paco and of the ERIC Forum for that matter. And we also want, of course, to have a bigger coordination with EOSC and to address also how we can use the physical infrastructures as flagships for EOSC, and you are doing that already in the context of your cluster, and we have foreseen some continued support from this. Other big topics that are important for infrastructures are, of course, the digital transition and the greening of infrastructures. The current energy crisis affects, so we need long-term but also long-term measures and standards. And for the digital transition, we look at it from a much broader perspective, not only EOSC, but also the data infrastructures that we need, the actual, the remote, for example, the remote control of equipment, instrumentation, the digitalization of data, to just name some examples. So these are areas that will definitely affect you as we will be coming towards you to consult you on your needs and then to think of future actions. And maybe last point on my side for the moment, Horizon Europe. Horizon Europe, we are in the process of finalizing Work Program 23-24. Calls should be published by the end of the year. And in that context, so we are quite advanced. In that context, we foresee support for the continuity of clusters, because we are convinced that it is important to continue working the structuring per domain, because each domain has its own specificities. At the same time, we expect to have also support for regrouping your needs, especially for EOSC, but this is not to the detriment of your own special characteristics assigned cluster. It's just addressing common areas for the future, and maybe having the opportunity to address also other areas which are not currently addressed. And there are, of course, many other ideas for possible support. Maybe I stop here, and I'm happy to come back. Thank you.
Does anybody else on the panel want to comment on that, or comment on what was said, or the audience? I can't actually see the audience. If not, I would just say, I think with the clusters, we have seen, working with the other clusters, that there is an awful lot of synergy between the clusters, even though we have very diverse scientific goals. There's a lot which we have in common, for example, around career development of scientists who specialize in computing and software, or in lots of other areas, but not necessarily to do with their science directly, but to do with the organizations, the people, and the way they work together. So I think recognizing, I mean, I heard you recognizing that in what you said, and I think that's very important, and I think that's something we certainly intend to build on in the future, is the strength of the clusters acting together. Was there a question? Yeah, Giovanni.
To be more explicit, I believe that I'm happy to, because a few of us attended this meeting that you led, and we are happy to learn that there will be a second round for next perspectives. But I want to be more explicit. This is my personal opinion, but I suppose that is shared by many people in the room. The cluster action has been your success, has been the Commission's success as a tool, and our success because we provide the content, and the fact that we are in a continuation now of the cluster means that we want to work together. And as I used to say, there is also not only the top-down approach, the ESFRIs that want to work together. There is a clear bottom-up, the people, the community take advantage of this framework. I believe that the Commission should consider that the cluster could be, I say, the tool also for the other explorative or more or less consolidated calls like the SERV, the tech one, where there is the risk of reinventing the wheel or reinventing the association, while, in my opinion, as well as from your side and from our side, the scientists, the impact, maximizing the impact should be really high in priority. And I believe that leveraging something that is working, the framework in which we are already co-working, co-developing, and discuss together, we can really give us the possibility to participate with more efficiency in the framework.
Okay, thanks. Any more comments?
Now? Yes.
Yeah.
Right. A quick question on the role of service providers in research IT. So we have here the research infrastructures, but both in EOSC and also in this project, we have service providers of research IT, academic service providers. How does the EC, in its work program for the future, see the collaboration between, say, the academic research IT service providers and the research infrastructures? In terms of, like, how will this ecosystem move forward towards the future? Do you have a vision for that?
Yeah.
Yes, maybe I pick up on the first point, I think that we definitely share the vision that there is a lot of benefit of building on the clusters. That's why we also foresee continuity. I didn't go into the detail because this is not an info day, but it coincides, let's say, with our vision. And also, for those of you who attended the workshop that we organized on the RNI needs end of March, we insisted a lot that we have a lot of, in an area such as the research infrastructures where we have to plan long term, we really need to build a process for Horizon Europe whereby we manage to work on the basis of roadmaps or of common areas of interest, let's say, which have to be organized bottom-up, including yourselves, the infrastructures and the operators of those infrastructures, either individually or in the form of clusters, and make sure that we develop a more structured approach in order to have a long-term vision of where we want to be. This is not to the detriment of bottom-up fundamental research, and we have many tools to do that, but we really need to build this, and we can only learn from good examples such as this success, which has been a joint success. So just to say that I fully understand your point, and we're working on that. If I understood correctly your question, because I didn't hear the beginning, I think the question was whether there is a vision regarding the role of universities and infrastructures in general, yeah?
So the role of research IT providers, so academic providers of IT.
Sir, there's people on Zoom, they don't hear you.
Yeah, but this thing doesn't work. It falls away. Anyway, so I hope you hear me. So we now have a lot of academic research IT providers that play a role in the ecosystem of serving the research infrastructures with IT needs. So data, storage, data management, those things. We have the European Open Science Cloud, so we have EuroHPC around. It's not clear how those links yet will really work. Currently we have some of the products in EOSC-07 as the exchange. They may not really return in the next work program. So I'm wondering, how will we really create an ecosystem out of both the researcher, the research infrastructure, and the research IT providers? Are there visions on that?
Yeah, I think this is a question mostly for my colleague Michel Schub, who will be here in the panel tomorrow, if you allow me. I prefer that he develops this point. I'm happy to comment on other annexed questions, but I wouldn't like to dwell a lot on this point, if you're okay.
Yeah, that's fine.
Yeah.
We take that tomorrow. Thanks.
Yeah.
Thank you. So I think we should probably move on a little bit. Thanks, Apostolia. So next question is to Federico. So CTAO is going to become an ERIC. So from your point of view, in order to enhance the participation of the CTA community in the uptake of open data, intensive open data research, what are the key elements that need to be considered to keep the forward movement of the ESCAPE program? And how will CTAO and the CTA community work within ESCAPE in the coming years?
Thank you very much for this question. Indeed, I have just to have a premise that we are extremely happy to be in the ESCAPE because we took really consistent advantages to be part of the ESCAPE. And I will clarify to you why I'm telling these things, because I believe that each of the partners of the ESCAPE are in different, of the research infrastructure, in different phases of the evolution. For example, ESO has 60 years of activities, so they are doing new instrumentation. SKA has a Pathfinder with several telescopes. At CTO, we have one telescope for the moment. The reason of that is not because we are not working very hard, but because in 2016, the shareholder decided that the construction of CTO would have started only after that the legal entity that will manage CTO will be an ERIC. So finally the application for the ERIC has been presented at the end of May, so the European Commission is analyzing, and I hope that beginning of next year they will be promoted to be an ERIC, so the big money will arrive. But clearly when you have to prepare the construction of a huge system of telescope with many complexities and taking a series of decisions, like, for example, decide which sort of instrumentation will be implemented on the site, how to organize the layout of the telescope, how to organize the power system, how to organize all the technical aspects that will allow to the ERIC to start immediately from the first day the construction, because we are spending already many years, so the expectation of the scientific community is very high. I just want to remind you that already today, several times, one has talked about multi-messenger, multi-wavelength science. As I say, everything started in 2017. I was on the other side at the time, and it was very exciting. But it's clearly that there are fantastic perspectives in astroparticle physics for the future, and gamma rays are key instrument to analyze the universe, related to many other wavebands. So it's important to create as soon as possible the observatory. So we prepare these things, but in a situation in which our staff was very limited, because the shareholder obviously could not do many investment in this preparatory phase. So we were really understaffed. So the participation ESCAPE demonstrates the fundamental role that this combination of knowledge and organizing very efficiently work program has been beneficial for CTO. So I wish to again to come to our specific organization and objective. Software for CTO is as important as hardware, because one of the aspects of CTO is not we have just to let's say, obviously operate a telescope in remote situation, very harsh environment, and take data, transfer them to the scientific community. But for us, there is a peculiarity with respect to the other astronomical instrumentation, because the atmosphere is like the calorimeter for particle physics. So the interaction of gamma rays with the atmosphere is very similar to what happens in the accelerator. So we have to model, to understand what happens between the gamma ray, the extremely high energy photon, and the very weak signal that arrives on the telescope, on the blue light. And this takes a lot of simulation and analysis using specific instrumentation that as Pathfinder we have already located on the site. By the way, this is a very nice situation in which I believe the presence of several clusters has been useful for us, because this has simulated to us to study atmospheric condition in an environment where the cluster for studying atmosphere is not having instrumentation. So we may contribute with our data to their work. And also the cluster for energy. We have been discussing and successfully with ESO to use a photovoltaic plant to provide energy in the Chile site, together with their idea to provide energy to the LT. But also on La Palma, we are studying new energy, the clean energy, to be used for the numerous telescopes you have to invest there. So again, this is a stimulus related to the activity of the interaction with the other cluster. So coming to the key element, action, and values, I see also hearing the communication of today that there are various aspects. I took some note because I want to be precise. So in my opinion, we have to focus on data and research software. We have to focus on science projects that will connect the research infrastructure within the multi-messenger, multi-wavelength to enhance aspect of interoperability. To add also theory and modeling aspect as part of research analysis software. There are also other aspects of science operation, like scheduling, proposal handling, support for the user. And I think it is a nice opportunity also to prepare interface for the user as simple as possible, because going toward the multi-messenger astronomy, it's clear that scientists from other fields would like eventually to make a proposal, a brilliant proposal to other system of telescope and other system of observation of the universe. So if we have friendly interfaces, that clearly the ideal place where this can be done is ESCAPE. This can be extremely useful for the future. Another aspect that is related again to the very important plan of the European Commission is the training and school. This is crucial because now the research infrastructure in astrophysics have a long life. After big investment, one considers they will last several decades. So it's important to prepare the new generation of people that, starting from what we have done now with your experience with preparing the software, etc., will be the one that will evolve and will upgrade the new system. But this can be done only if there is a transfer of knowledge from the present generation to the future generation. So we have to take care about that, because this is crucial to be sure that the leading role that the European research infrastructure are now already having and increasing their role will be maintained in the future decades. And I think this is part also, ESCAPE should consider also, already has done works in this direction, so but in the future also should be even extended. To answer the last part of your question, Jan, I think that we have signed the commitment for the ESCAPE for Future, and we'll be very interested to continue our participation on obviously data lake, data management, development of software, science platform, all the aspects, according to the decision of work program, because it's clear the definition of work program will define our future interest, and hopefully within the solid financial and staff situation in the future. But on this aspect, I'm really optimistic, and I think we will provide the contribution to this future project. Thank you very much.
Thank you. I think it's interesting that you point out the software, the training, and the schools, because I think when we were preparing the ESCAPE continuation, the collaboration agreement, this was certainly one of the strong threads which came out. And this is also something which comes out again and again in the discussions with the other clusters. So this is really a strong thread which I think everybody is interested in. Yes, please.
Can I comment?
Yeah, please.
On this education and training part, which of course I strongly welcome, it's very important. I said before that there will be an increased effort for deep tech talent in the coming years from the Commission side, and also, and this will include mobilizing different types of programs, so Horizon Europe, but also Erasmus+. And I think that this is an area where a cooperation with universities, a more structured cooperation with universities, is very important. So training is about understanding actions in the local constituency, but a more visible action at the level of the cluster, which involves really astronomy, particle physics, I think would require also a partnership with universities. Currently with European universities, there is a nice testbed to pilot joint programs at European level, curricula, even joint degrees, and so on. So maybe there is something to consider in that context as well.
Yeah, we have some strong ideas in
sure.
that area of what we could do. So let me move on to Paco, which is basically a similar question. But from the point of view of an infrastructure that's actually in operation, so JIVE in this case. So what do you see as the role of the cluster ESCAPE, and what would you like to see which would help improve the cluster approach for JIVE? How can ESCAPE help JIVE and fundamental research?
Yeah, well, thank you very much for the opportunity to participate in this panel. I can say that the participation of JIVE in ESCAPE has been useful beyond any doubt. Okay? So it is clear that, even if ESCAPE has this ESFRI word on it, and JIVE is not in ESFRI, and the JIVE is not in ESFRI possibly because, JIVE started because the ESFRI concept was even thought of. But the true thing is that We have been, well, it has been demonstrated today with 3 of the presentations that there are needs for the infrastructures, and that even if the infrastructures possibly are going to tackle them anyway, in our particular case, the ESCAPE collaboration has brought both an opportunity to work together with other partners who have the expertise and possibly share our own expertise with them, but most important to provide services and products that were long demanded by our community. So as it has been shown in the 3 talks that the Jive staff gave today, the participation in ESCAPE allowed us to put a bit of order into the archive of the EVN, creating the tools that are necessary to put this archive in the virtual observatory. So, as I say, this was long demanded. It was possibly not an easy task. It was not done before. It has been said as well that the characteristics of the radio astronomy data, and in particular the BLBI or interferometer data, are quite different to what we in general see in this virtual observatory, but nowadays it is a reality. So I think this would not possibly have happened, or at least not in the timeline and in the way it has happened without the focus and the resources that ESCAPE has provided. So in that sense, I think, well, there are some specific advantages that we have been benefited of. The software, of course, the possibility to make containers with the software, the learning better what EOSC is and aligning our processes in that direction, creating these tools for the EVN, making sure that our data is fair, which is, well, the F of findable was, as has been said this morning, quite a challenge, and possibly still is in a sense. Creating these tools, Jupyter Hubs, and Jupyter notebooks that allow us to work where the data is, and also this will be useful for the future facilities like the SKA or others who have huge volumes of data. It has just been mentioned, thank you Federico, the training. I think training is one of the possibilities also that we look forward to be developed also through the clusters, because what is sure is that the research infrastructures are hubs of knowledge. This is the way in which the young generations can benefit, and the users. There have been a number of already good examples. EDIS was mentioned this day in a different context, different kinds of projects, but this would be very much something that we would support. I think on my other hat of ERIC Forum, I will possibly be asked a different question, right? Okay, thank you.
But maybe if you want to say it now, that's fine. I mean, go ahead. Yeah.
Okay. Well, no. Well, it is a long day for me. I apologize. a long 2 weeks. Yes. ERIC Forum. So I'm the current chair of ERIC Forum. This is a bottom-up collaboration of 25 research infrastructures of kind ERIC. This ERIC, as it was said, is European Research Infrastructure Consortia. Jive ERIC is one of these. And actually, this bottom-up collaboration, well, has been working for a number of years now. And it is, well, in a sense, quite aligned with what ESFRI is, because 23 of these 25 ERICs are in ESFRI. Jive is one of the exceptions, as I said. And as a consequence, possibly, the ERIC Forum is organized precisely in clusters, the same as ESFRI is. So there are five clusters in the ERIC Forum, and this allows us to work together, but also helps in the governance, because there is one representative of each cluster in the executive board of the ERIC Forum, etc. So what happens with the ERIC Forum is that, it represents the actual research infrastructures, in particular these ERICs, in a number of different scenarios. Leah has talked about the ERA forum. Also, we have a specific association with the EOSC-Association. The ERIC Forum is a mandated organization in EOSC-Association, and it means that, or we have collaborations with Aero Forum. I guess we will be possibly discussing some of them later. But the question is that the ERIC Forum is a good contact point. Well, we used once honest broker, and somebody did not like the word broker, but in any case, the question is that the ERIC Forum is this possibility to engage in the different collaborations. So this said, when we organize in clusters within the ERIC Forum, we find some challenges, and I think these challenges could also be seen in other contexts, and in particular relevant for the discussion today. I mean, one obvious challenge is that many activities, the same that many of the objectives we try to solve, are not, let's say, associated to one cluster or to one theme. There are ERICs that belong to several clusters, right? Health, science, and environment, for example, right? And that possibly means that the clusters themselves in their own structure are always a bit incomplete. So you don't have all the research infrastructures in all the different kinds of clustering that we find in the landscape of infrastructures. And I think this will be also an important thing, because what we do today in ESCAPE, or what are happening in the other clusters that are devoted to EOSC, is very much complementary to what is happening in other clustering scenarios, in my opinion, like happens in Euroforum or ERIC Forum or even ESFRI. And one example would be, for example, that the research infrastructures that are, for example, in synchrotron or lasers, they are in the PANOS cluster, but they are also in LIAPS cluster or in LENS, and in different conditions they are answering possibly different questions. And we possibly would like to keep the relevance of each one of them and bring them forward in the specific conditions in which we want to do our activities. I think for the moment.
Thank you. Thanks. Just on that point, do you have a suggestion about how we can go about that? Because, as you say, a research infrastructure has a different voice depending on which context it's in. So.
Yes, I think well, I don't have an answer, of course, I would love to. I think what happens is that there are different points of view, and each one has some advantages. And we have a lot of experience in the collaboration between ESFRI and ERIC Forum, for example, also with Aero Forum, with the clusters, thematic clusters, like the one for EOSC. And I think each of them have, as I say, some advantages. Now, of course, we all want to have some simplification of the landscape because it's complex, but it is complex. And I don't think it is easy to just, find one simple solution to all, because then we will get into the trouble of not having this diversity that is currently happening.
Yeah, go ahead.
Of course, Leah.
Sorry, I don't want to monopolize the discussion, but I gather it is possible to have some interaction. Yeah. Sure. Linked to what Paco just said, and also to what I said before about the landscape analysis, that we reopen the methodology on the landscape analysis. I believe a fundamental element is to ensure that we have the right classification per big domain by discipline. And therefore, I think it is inevitable that whether we call them clusters or something else, that infrastructures that belong to similar disciplines belong together in either we call them strategic working groups in ESFRI or clusters and so on. We have the same approach, and there is a tendency for such organization. At the same time, research infrastructures are asked more and more to contribute to several areas. This could be cross-cutting transversal elements like EOSC, or it could be what you can do for societal challenges, and it's more or less obvious depending on the infrastructure, or there are transversal elements such as researches that you mentioned before. And therefore, we also need to address interdisciplinarity or transversality, and this requires some additional organization. So I'm afraid that it cannot be super simple. And I believe that grouping the different needs and speaking with one voice, depending whether it is about the specific discipline or the cross-cutting or challenging aspects, I think it's important, very important, because it brings a relative weight, economies of scale, and the kind of legacy we want to leave for the future as well. So that's my contribution to the discussion.
Okay, thank you. Are there any comments? I can't actually see. Do we have comments from online or anything? No. Ah, yeah, go ahead. Where was it? Yeah.
So thank you very much for getting the opportunity to contribute. My name is Andreas Petzold. I'm as a guest here, and I'm the coordinator of ENVRI Fair, which is the kind of a sibling to ESCAPE. This is a cluster of the environmental research infrastructures, and we were invited here to share experience among the clusters. And so I'm really glad to hear from the panel which importance you put on the shoulders of the clusters, and I fully agree that we are ready to take up the role. And although we are working in very different fields with very different communities and very different tools and even philosophies of collaboration, it turned out in various of the joint meetings we had that our needs and our strategies, what we decided to do in the clusters projects are surprisingly similar. So what you saw today for the ESCAPE cluster, you can see something very similar for the environmental research infrastructures, what we are going to develop. So here I think we can make really an important contribution from the clusters, independent of what topic we are working on. But I want to make really an argument that we need to maintain the complexity and need to consider the very different fields the clusters are active in. So our environmental research infrastructures cluster cannot be organized identical to ESCAPE because our way of working is completely different. And also our customers for the data are completely different. And that depends or determines a lot of how we work. So in that sense, if we can keep this diversity alive, I think we can further develop as an important part in ERA and can maintain that our leading role. And the only plea I want to send to the panel here is really to make sure that the clusters can further develop as clusters, not only thematic-wise, like we can do in this InfraServe and InfraTech proposal to develop tools, but also to further develop as clusters by itself. And the thing, and that is maybe an argument or a point I want to bring to you, Apostolia, is the role of the clusters in the landscape analysis and the further development of the landscape should be a bit more pronounced in a way that we want to be closer included when it comes to the point if we have identified gaps of research in the certain field, if new research infrastructures should be founded, if the capacities of existing research infrastructures should be expanded, or just to keep the landscape manageable and not make it too complex, because then it may lose its functioning, and especially when it comes to the interoperability of various research infrastructures, we need to be a number which is manageable. So if we are too many, then collaboration becomes really difficult. So keep the landscape as simple as possible. We really appreciate very much the role you see for us, and we are happy to contribute as much as we can. Thank you.
Thanks, Andreas. Okay, maybe if we come back to this topic at the end, because I think there's a lot of interest in the future of the clusters and how we'll manage that. But I think we do need to move on now. So let's go to Christoph. So Christoph, as a member of the external advisory board of ESCAPE, you have a sort of special view of the project. So you've seen it develop from the beginning to where we are now, and you've indeed provided suggestions and things that we could do. So from the point of view of the advisory board, for the benefit of the scientific community, what do you think is the value of ESCAPE, and what are the major expectations for the future work program?
Yep.
And then the second part of the question is, from your inside view of ESCAPE, and with the idea of bringing more space science into ESCAPE, how could ESA contribute or leverage what we've already done? So I think you've seen the question.
So thanks for allowing me to participate to that panel. I think the first thing that struck me the most is the capacity of the project of ESCAPE to bring together all the ESFRIs and the various partners. I think it has been very clear, especially during this difficult time of the last 2 years. And I think that's really, I felt that very strongly also today throughout the presentations, where every work package actually had specific presentations of how the work done has also been bought in by the partners, and I think that's really important in that context. From the ESA perspective, I think what was the most valuable for us is clearly the work that has been done in Work Package 4 in the context of the VO. I think I felt I could even probably have presented something a bit like Martino did for ESO, because clearly from the ESA perspective, all the work that is being done in the VO is very important to enable this data interoperability, this new era of multi-messenger in astronomy. I often say one of our recent flagship mission, Gaia, all the data that is being accessed, all the Gaia data that is being accessed is actually being accessed using VO protocols. So that's really for me the clearest importance why the VO is important. Maybe about the major expectations for the future work program. I think that now that the first part has really brought all the ESFRIs and the data centers together, maybe you need to look a bit more at the user and the end scientist perspective, how to bring this. I think we will hear tomorrow about this science, the test science cases, in particular about dark matters on the extreme universe. So I think that's something also that needs to be looked should be taken further into account in a potential future work program. I think the VO needs to continue. It has been mentioned a couple of times. The science platform is clearly something that is a paradigm shift that the community is going towards. And I saw a lot of progress in individual work packages. We've been as an external advisory board also advocating for further integration amongst the various work packages. So there has been great progress also in that context, and I can only encourage you to continue in that directions, that all the big pillars that were necessary to build now can also have further synergies amongst themselves. And then on the second part, how could ESA contribute or leverage? I think that we are involved in the VO and in setting up the standards, in implementing the standards. We also have our own science platform, ESA Data Labs, and I think we need to also cooperate with the ESCAPE projects, because we are doing things we are serving the same community. So clearly we need to work further together. On speaking about community and also what have just been said about the various scientific disciplines, I think that maybe we hear a lot about astronomy and particle physics, and maybe ESA in that context can also, we heard a little bit about heliophysics with the SolarNet presentation earlier on. Planetary science is also very key to ESA's space science program, and it's maybe one thing that could be brought also in that context. And then the last part, which is how could ESCAPE could work. I think that I've started to also engage. It's really good to be able to physically being able to be present and have networking and discussions with people. And I think that some of the things that I think could be very beneficial for ESA as well is all the work on the data lake, and we've had some discussions with Xavier also earlier on. how could we connect ESA space science data into the data lakes, or how could we use data lakes technology for some of the ESA programs, such as maybe Euclid, or in the future LISA also. And also, with regard to the EOSC, how can we connect the various science platform, and in particular our science platform, also to EOSC computing resources is one thing that still I'm trying to find out how to do. And that will be the opportunity to work more closely together in the future.
Yeah, I think that's probably an area where we all need to work together to understand how to really integrate with the EOS, because I think there's a superficial level, but then there's probably a deeper level we haven't really understood yet. So I think that's certainly a collaborative aspect we can explore. Giovanni, yes. Oh, wait, we need the...
Christoph, something that I think we never discussed together, but in the introductory talk, I talk about a wager and a human adventure. And you realize also that in the work packages presentation, the question of human adventure comes again. I say many times, it looks like that the cluster action is top-down because the Commission asked for the commitment of the legal entities. But at the end, it's much more bottom-up because people are willing to keep working together. Mm-hmm. I believe exactly as we are doing with ESO or with CERN, I believe that there is a potential for the community at large to work with engineers, scientists for ESA. Mm-hmm. There is a kind of potential flux and cross-fertilization. We talk about training, but there is different forms of training. Even discussing take part to the working group. I think there is a huge potential to bring ESA people together with scientists in the university and the research. That's the comment. You are not obliged to say how it works.
No, I have no problem to answer here. I mean, it's very clear, as I said, we are serving in particular in that science cluster, we are serving the same scientific community. So, I would be more than delighted to work even more closer, to participate more actively. Now, obviously, space science in ESA is one part of all the ESA activities. And there are lots of ongoing activities between ESA and the European Commission, being on navigations, being on Copernicus for the Earth science, on Earth observation activities, and I'm sure I'm forgetting some. And obviously, the type of agreements which are done between ESA and the EC are much wider, and for the time being are focusing more on this big order program, rather than the specific space science. But okay, I'm still open, but not all the decision is just on me.
Indeed, I think the agreement in Commission ESA is mostly linked to the, let's say, to the kind of competence that politically has been agreed to be carried by the Union. And there it started more on the application side, Earth observation, satellite navigation, satellite communication, more recently. But it has expanded also, for example, to space science, space weather, space debris, and so on. So I think more and more we are bridging to your direction as well. And there are interesting initiatives also happening also from the space research, Horizon Europe Space Research, and I think probably a connection there could be relevant for some parts. I think of, I don't know, critical space technologies, for example, just to give some examples, data exploitation and other things that are happening as well. So I think there are small bridges also constructed.
There are many bridges on the European Commission, of course, yes.
Okay, thank you. So I think we should move on. So the next question is to Martino. So ESO has supported the development of the VO and the integration of the VO Alliance in astronomy with actions led by other communities within ESCAPE. It was a gamble and also an opportunity. So what do you see as the balance at this point in the project? What do you think ESO still needs to do in the future to make the cluster action a success? And what do you see as the next collective challenges? Are they sociological, technological, scientific, or more than that?
So thanks. Yes, I would start from not answering, but taking stock on one word there, gamble. I don't think it was a gamble at all. First of all, because generally speaking, we don't particularly like gambles. And this is not just the way we operate. And second, because I think that ESCAPE built on an excellent line of ancestry, if you will. So Asterix was before ESCAPE. The VO was a reality before any of this started through EuroVO and other initiatives. So I think that there was a very important reason why we decided to join is that because we knew what to expect. What we wanted to expect, what we were expecting to expect, if you will, is results. And this is what happened. And this is, I think, the reason why also the ESCAPE Open Collaboration is such a good thing, because it builds on the success of ESCAPE. So I think that this is a very important thing, one step at a time, and then moving forward and forward. So that is one thing. So having said all of this, I think that we mostly got out what we expected, so which is the support for the VO and the larger community is really something that was extremely important to have, and I think that ESCAPE delivered, as I tried to articulate a bit more in detail this morning, and also what Christophe was echoing before. So I think that the balance is certainly positive, and because real progress was actually made on that. Then we also explored some more adventurous things like applying AI for the first time at ESO to the massive data, to try to create new content through novel techniques on top of what we already had. And also I think that we learned a lot out of that too. It wasn't the focus of my presentation here today, but so by and large, I think that the balance was very, very positive, and really an action like ESCAPE enabled it by bringing people together, by bringing all of this together. So I think that, so I hope that this answers at least the question. As for the future, what will make the future a success? From our perspective, I think is that insisting on the science side of the EOSC, of the science side of exchanging data. There are, of course, technological challenges, how you shift data around, how you store this fantastic amount of data, and this needs to happen. But in parallel to this, together with that, in harmony with that, we need to focus on the science and the content of the data. So not just bits and bytes, but what do they mean from a science point of view? And this is another thing that ESCAPE did very well, and I think that this needs to carry on, and I think that the open collaboration sets, again, a very good frame to doing that. So that is one, so delivering added value. One other thing I would like to mention linked to this is that when it comes to data challenges, volume is not the only thing. You can have data sets that are small in volume, but incredibly important in terms of science content. And I think that this focus needs to be kept. What else? I think that the interesting thing about ESCAPE, and which again I think will be interesting for the future, so to make the future a success, is this mixture of old research infrastructures like ESO. So again, ESO is turning 60 this year, so that's a long time, and newer ones who have not seen real data yet. And I think that this bringing all together, having a forum to bring the old and the new together, is really important. The new can probably learn something, at least, from the older ones, and hopefully the older ones, like us, can get a sort of a gentle kick towards the future from the newer ones. And I think that this dynamics is really, really important, really, really important. And again, the open collaboration, again, offers a forum to do that. And I think that this is looking at my notes, yeah, that's basically the gist of what I wanted to say. Thank you very much.
Okay, thank you. I think probably part of the gamble was letting particle physicists join astronomers. Any other comments or is that, yeah, so, yeah, please.
If you have a microphone?
Yeah.
Yes, very provocative start for my comment. So do we really need to train so many astronomers and astroparticle physicists as we do for society? I think no. Do we really have to solve the questions in astronomy that are puzzling us for the sake of society? I don't think it's the most important thing to do. I think ESCAPE is a real success because we managed to get data from the providers at the place where science happens, the data centers. And by doing so, we are actually in astronomy currently building the largest platform actually with free data, with standards to make it easily accessible to train the next generation of data scientists. And we give them challenging problems. We give them things like black holes, where they think, oh yeah, it sounds cool, like we heard in the talk. And we give them interesting topics to develop the skills and needs we need actually for society. So I think we get two problems solved. We get our problems in astronomy solved, and we got the problem solved of building a platform for training the next generation of scientists. So I would be interested in your comments on how do you think the landscape is evolving? What's coming next? So what are the next steps we need to do to actually turn what we currently build as a platform for doing data science in a platform for training the next generation of data scientists?
Okay, so I think that's a very interesting question, and you answered part of your provocative statement yourself. And can we leave that to the end so everybody else gets a chance to speak? Because I think that is an interesting question, and we'll come back to it if there's time. So let's move on to Antonio. So the ESCAPE collaboration represents and operates cross-research infrastructure in data management. So we've been doing that with the data lake. Can we see how this competence and the services that we've built act as lever arms for further supporting regional data management for the SKO scientific exploitation? And as you know, in the particle physics strategy, it was mentioned that the policies on open data and data preservation were very much encouraged, and we need to have sufficient resources invested in implementation, with the ESCAPE given as an example of that. So from the perspective of SKA, SKO, and the regional centers, what do you see that ESCAPE has done that wouldn't have been possible before? And what are the priorities and domains where we should focus our efforts in the future, particularly for radio astronomy and SKA, and again, the role of the cluster?
Thanks, Ian. I'm not sure that my answer will be shorter than your question, but I'll try. Firstly, I think I should maybe mention two things. First of all, you've mentioned the SK regional centres. Now, formally, the regional centres are not part of the construction project. We started the construction project. We are now building the observatory, but the SK regional centres, where the science will be enabled, where the scientists will access their data from and do their science, is clearly crucial for the success of the observatory. But they're not formally a part of the project. So our role really is to encourage, guide, and enable the formation and development of an SRC network where this can happen. And I think the other thing I want to also say is that our involvement in ESCAPE has been really profitable for us and really advantageous for us, But the main outcome for us has not been the services. It's really the development of the expertise that we have gained in being involved in these projects, in these work packages. So the expertise that we've gained in data management, identity management and access control, the science platform work, they will all feed into how we form that SRC network. So those are the two things I want to say. So we've already started our agile development of the SRC network, and within that work we are deploying prototypes and doing development work, and it's what we have learned from being involved in ESCAPE that's really has fed into that and is guiding the work that we're doing under that development. The kind of enablers that we've seen from ESCAPE project for the SRCs then, well, you know, there are several I could mention, and I probably will. So the IAM, you know, so our services are ready to support the prototyping that we're now starting. So we need to support access from different disciplines as well. I've often said this in the past, if when the SK is operational and if we're not receiving proposals from JWST or Euclid astronomers or from maybe even KM3net or any of the other ESFRIs that are around, if we're not receiving proposals from multi-messenger facilities, then really we've failed. So we need this access to be as fluid and the bar to be as low as possible and yet still secure, etc., etc. The science analysis platform work, well, we will continue to use what has been developed, and we'll continue to use that in developing our platform for the ESK regional centres. We will need to incorporate data from other observatories, and clearly the metadata queries, as we heard today, you know, virtual observatories is clearly key for how we want to make that happen. And we're even using VO protocols within the telescope. You know, where transient alerts, for instance, you know, we're using VO protocols to enable that so that we can quickly and rapidly respond to those. And just to show our commitment, really, we've only recently joined the IVOA Alliance, so we are now members of the IVOA. So in some specific areas then, in data management, for instance, we heard a lot about that today. And really, it's what I see as the backbone, you know, without which nothing will work for us. If we're not able to deliver the data from the observatories and put it in the right places, then everything will fall apart. So the concept of the data lake, the management of that work through what we've been using, the Rucio platform, has seen some successful prototyping happening. But now what we need to do is start to scale. We need to scale in terms of the number of data center sites, nodes, that we will use. We need to scale in terms of the volume of data that we need to send around these pipes around the world. We need to scale in terms of the rates, the data rates that we are using. And we need to find out when the thing breaks. Once we know where it breaks, then we kind of understand where our limits are. We need to try and do that. Data processing, we've heard a bit about this today, and in fact, you know, in my notes before this morning, I was going to say, well, we've heard nothing about this today, but we've heard a little bit about this today, and it was interesting to hear Matthias Füssling talk about asynchronous data processing, and I think that's something that we may definitely need to do within the SRC regions. But maybe also we also need to think about distributed processing as well, not just asynchronous, but asynchronous and distributed processing. These data volumes that we will have will be, you know, significant. They'll be quite large. So how do we best process the data? Is it better to have all the data co-located and then we process the data there? Maybe the processor is not as fast, so maybe it might be better to move the data to a place where the processing is faster. Or is it better to do it asynchronously and distributed? I don't know the answers to those questions, but I think we need to know the answers to those questions. And finally, something I also was going to say we hadn't heard of today until I was here for the talks today, but ingesting these advanced data products we heard from Jive this afternoon. And once you've created these advanced data products in our nomenclature, we want to put those back into the archive. They need to be discoverable again for other users to use to compare with their catalogs. So how do we do that? We need, obviously, provenance, protocols. What are the protocols for doing that? And this is where sociology comes into it. I think it was mentioned in the previous question. We are now starting to push and do things in a different way. It's that phrase I don't like, a paradigm shift in a way. We will not be delivering visibilities to our users in the main. Our main products will be image cubes, not visibilities. And so that is difficult for a lot of radio astronomers to accept, and it continues to be difficult. But we need to keep doing that. James showed the data flow through the telescope in one of his slides. And if you take the correlator output, which is of the order of 1 terabyte, maybe half a terabyte per second, we'd be generating of the order of 45 to 80 petabytes per day per telescope. Yes, maybe in 10 years from now we'll just shrug our shoulders at that. Maybe, I remember 10 years when I thought having 1 terabyte on my laptop would have been a dream, but we're all quite used to that, and we probably all have that on our laps at the moment. But at the moment, no, it's not going to happen, and so that is not where our thing is. So those are the kind of ways I think that future ESCAPE projects need to look at from the SKA perspective. To address now what has been enabled by ESCAPE that probably wouldn't have been, I think, first of all, let's just celebrate how we've managed to get this broad and diverse community together and to get them to work together on common goals, things that we all agree need to be done, but we're doing that from quite diverse communities, So those common goals I've already mentioned, data management and the science platform. It's not just organizing where the data goes to, but we know where does it go to allow for the efficient execution of the science program. That's not, computing resources are not cheap. But also for us, for the observatory, to be able to do that allows the science program to be executed efficiently at the telescope level. We need to be able to push that data out because our science data processor is an integral part of the telescope. It does where all the real-time calibration goes on. And so if all the resources are taken up and we cannot create all the data products, if we were to invite the user community to produce their advanced data products at our science data processors, we would just not be enough resources. And so that would affect the execution, the observing efficiency of our telescope. And allied to that, no user of the SKA will have direct access to our SKA systems. So the science analysis platform is crucial for the community. That is where they will access the data. That is where they will run workflows. That is the platform where they will do that, not the observatory. So in the future, I think we can and we should continue to work together with the science clusters on these common problems that we are interested in. But as I said, kind of alluded to earlier, we'll be deploying them locally within our regional center network. It's a global operation that we have. So we will have our own operational models that we will need to follow, for instance, data policies. And we have to keep in mind that even though this is a European forum, our community, our funding bodies, it's a global community. We're a global intergovernmental organization, not just the EU. Our host countries, all 3 host countries, Australia, South Africa, and sadly the UK, are not in the EU anymore. Yeah, and I think finally, before I can step here, again, I think we need to have increased and continued consideration of IVOA standards, continue to develop them, especially for radio astronomy, to enable interoperability. It's how I feel we'll ultimately be able to satisfy open science and fair.
Thank you. There's a lot there.
Yeah, sorry.
No, but it's good. And I think it's exactly this kind of discussion. So in some of what you were saying, I recognize the same problems that we see for high-lume LHC, that this issue about whether you move the data to the computing or how you optimize that problem. This is something which is getting worse, yes. Right? And we need to work on that together. So immediately, that's an example of why it's good to have this kind of cluster so that we can tackle those problems. And by the way, the data centers are in some cases common, so they see the problem from both sides. So it's really useful to work together. Any other?
Can I just thank you, Antonio, and confirm that the answer was longer than the rest?
Yes, I apologize, but it was a long question.
The answer, yeah, absolutely. Yes. Yeah, I can't see it. Yeah, please.
It's Chiara.
I can just see a hand. Oh, it's Chiara. Yeah.
Can you hear me? Yes. Thanks, Antonio. I completely agree with you. I would like to stress once more what you have, I think, mentioned twice, the fact that the SRC will be a partnership between SKO and member countries. And in particular, at European level, this will have an additional interesting challenge, that is the heterogeneity of the SRCs that member countries will be able to offer for the SRC net. And so I think that it's extremely important to keep this element in mind when discussing, because of course there is in this end-to-end partnership that we are trying to build, there is the SKO point of view, and there is the point of view of the different countries that will have to provide the SRCs. And so thanks, Antonio, for having stressed this. I think that it's extremely important to be kept in mind in future discussions. Thank you.
Thanks, Clara. Okay. We have a few questions left, so we don't have very much time. Let's move on. Another question for Federico. Do you see any collaborative ESFRI role or competence center that could be basically integrated with ESCAPE so that all ESFRI partners benefit from this, as well as new RIs that are potentially coming up?
A complex question. Fortunately for me, already the colleague has expressed some comment about the role of ESFRI interaction between ESFRI and ESCAPE. The paradigm of ESFRI is clear. They provide excellent science and excellent data services to the broadest community. So let's say this is a very nice overlap with the finality of the ESCAPE. But at the same time, it's clearly that an enhancement of ESFRI participation into ESCAPE can be achieved only with the strong participation of the research infrastructure themselves, that they should express their interest and their priorities, because this defines which are the aspects that on which ESCAPE can be useful and participate to that. Say that, so it's more ESCAPE that should try to adapt to what are the needs and the necessity of the ESFRI research infrastructure with the open dialogue. It's clearly that the domain-based approach is the easiest way, because this means that you discuss clearly and you can organize a project very, very well focused on which you test, verify, and obviously improve the performance of the software. That could also be moved to other sectors. There is no objection on that, but it clearly is a complex matter. So ESCAPE, in my opinion, could consider to address a few point on which the high-level quality of the ESCAPE product are evident, so data lake and data management. And this clearly could be an important responsibility that ESCAPE can have in the perspective of having a competence center that will be, let's say, led or with the priority defined by ESFRI, because in this sense, ESCAPE can provide a fundamental contribution. Also, data processing is another aspect. And not to talk about the science platform and science portal also on this aspect. Touching this question, not too overlapping exactly on this item, I believe that the idea of creating competence center or organizing the future plan in the vision of the European research area, so maintaining the extremely high level of the research infrastructure also is touching and could be considered by the European Commission in the future, the item of intervening on the sustainability of the research infrastructure and all the understand which are the fundamental instruments that will be in position to maintain the strong investment that the member has done to create the research infrastructure, because it's from my experience, I experienced various projects, large-scale projects, but it's much easier to get a fund to create an infrastructure than to maintain it. So it's a problem that the European Commission knows perfectly well. It's really strange, because when you ask for hundreds of millions, if the project created by scientific community that has a vision can be realized. Now with all the difficulties that we all of us know, but having the support for decades for operation, it's another matter that sometimes creates an embarrassing situation to maintain the high level of the infrastructure. So I believe that one could try to create a sort of, let's say, once the priorities are well defined by a dialogue between the community, like ESFRI, the ERIC Forum, and obviously led by the European Commission, define the priority, then a plan for supporting partial contribution. It's clear that the members that are constructing infrastructure should be involved, but also the user community should be involved in operation cost. But the presence of the European Commission could be something that is reassuring all the environment. And also, in my opinion, is also interesting for another aspect. If you want to have other members that are joining your infrastructure with important contribution on the, I have a couple of examples in my mind, on the hardware, on the software, or increasing the potentiality, scientific potentiality of the research infrastructure, is clearly quite attractive, the fact that there is the European Commission that is funding partially the operation cost, etc., because I think this reduces the problem, also eventually further partner to do the first big investment, then provide part of the operation cost. Imagine some, let's say, some partner like the United States, like Australia, like Japan, in our case, for example. That's quite important. And this can help to maintain the leadership of Europe. So for that, I believe that maybe it's an item that should be considered in the future. And this is a further comment I arrive at the end for young population that is here present. Competition in local, regional, European, global level is extremely important when you are discussing the concept and the prototyping. But then when you are realizing infrastructure, collaboration is a key word that should be applied, because competition will have to lead to the best choices, but when you have to consider something that will last 50 years, 60 years, 70 years, 30 years, you have to consider collaboration as a fundamental instrument to grant the future of the excellence of the infrastructure. Thank you. Sorry for this
No, thank
going
you. I think
away from...
that was entirely appropriate. Thank you. I think we have maybe one more question. So this one is for Martino and Antonio as representatives of international organizations. So in that context, do you see other aspects where ESCAPE can be of benefit to the international organization rather than the infrastructure itself? This is, well, in fact...
Okay, well, I think I can be short this time. Well, I think first of all, you know, as I said earlier, we're not an EU, a European-based IGO, so it's a bit different, I think, than most of the other research infrastructures within ESCAPE. But some of the things that are important to us as an IGO and, you know, part of our mission and vision include things like, you know, what are the societal impacts that our work, you know, brings? You know, maybe, you know, I think that should be more of a focus. You know, when we do the work that we're doing, you know, what are societal impacts that we bring? You know, the concepts of fair and open science are there, but they need continual championing, it seems. And so we should continue to do that. And my final point then is, as I said, you know, we're not EU-based. We are global. So I think one thing that ESCAPE can do that will bring, you know, the aspects that what we learn from ESCAPE that will spread that knowledge. So let's try and be, you know, bring more inclusivity, not just within Europe, but also across the world as well. So, and that is something that I think that us, at least as the SKA Observatory, we can help to enable there because we are naturally a global IGO. So that was going to be short.
Short and relevant. So what can I add? Probably just that, I don't know, I think it gives a very good anchor to the community and a different perspective on the community we otherwise might see. That I think is really, really important. Usually we don't think necessarily about, you know, universities or other research infrastructures as an IGO. So we have our member states, we have those reporting lines, those controlling lines as well, those governing lines, but not necessarily other ones. And I think that projects like ESCAPE are really good to have another reality check on what the community is about and what the community expects from us. So I think it was very, very important. And related to something that was mentioned earlier, ESO has been part through the ALMA part of ESO in regional centers as well. So, and again, perhaps what was learned out of running those things for 10 years could be useful for SKA. I'm sure it was taken into account, and vice versa. So this continuous reinforcement of the experience and the new perspectives, I think, is really something that, from our point of view, is really important. And ESCAPE and projects like that in other disciplines really foster that for as long as the end game is clear and the end game is generating science. So the content, that should really be the driving force of what we do.
Thank you. I think we've reached the end of the questions. There was another one for Postalia, but I think you answered that already. Yeah, I think you answered this already. Yeah. So I think that's the end of the questions. Does anybody on the panel want to add anything or make any other comments, or anybody in the audience in the few minutes that remain? Yeah, I mean, so can go back to your question, which I can't quite remember what it was. I mean, you had a comment about why do we need so many astronomers? Well, yeah.
No.
No, he said astronomers.
That's how I started saying ESCAPE is a great success, and bring data providers together with those enabling data analysis provides us with a large platform to train the next generation of data scientists. And I ask for your ideas. What are the next steps on providing an infrastructure to solve the puzzling questions in astronomy and keep the endless astronomers busy? Yes. But in the meanwhile, train the next generation of clever data scientists that transfer the knowledge they learned on complex problems in astrophysics to things to start their own startups for whatever society really needs. So I just wanted to have your ideas on that.
Does anybody feel they would like to comment on that? Yeah, Stephen.
I think this is touching on some a lot of related important areas. One is that we have a metaphor in academia of a leaky pipeline of people being trained in astronomy or particle physics and then moving out. Another is that there are a lot of initiatives. I can say this at least on a national scale. There are a lot of initiatives for trying to engage academia developments in data science with SMEs and businesses and so on. And the third area that this is reminding me of is that there is not a good career path for people working in technical areas. And the thing that is connecting this, I think, is the fact that academia pay is terrible. So the reason that we have a metaphor of a leaky pipeline is that people come out of academia into other areas. And, you know, academia does not have a monopoly on interesting questions to work on. There are lots of other things that people can work on. And then they get used in industry to a much more elevated salary. And then we can't bring them back. So it would be wonderful to have a two-way membrane. But the fundamental problem is we don't have the career pathways set up for technical people. And those that we do train go to much better paid places. So I maintain that a good solution to improve the links with industry and improve the cross-fertilization of ideas between the industrial world and academia and develop astronomy on a technical basis is to pay us more.
So actually, I have two comments. One serious and one frivolous. Which is the serious one is I think this is entirely related to what we were discussing earlier about in the next round of calls trying to address this whole area of career development, not just for young people but permanent career development. And the other is you should be careful what you wish for, because one of the factors in, I can't remember whether it was the 2008 crash or the one before that, was particle physicists leaving particle physics and going to work in Wall Street. So, and automating the sales. Yes, please.
Path, and I apologize for that. I think it's not only about the data scientists, is what can happen if all this data is available out there with the right format and the right algorithms that can generate spin-offs. Can we create value on this data? I think this is maybe another path that could be considered in the future.
Can I make a comment, a serious comment?
Sure.
I remember that during the meeting that you organized with the stakeholders, we put on the table this issue, and also when you were kindly invited by the clusters we have the meeting, I asked you about the combination of the European initiatives and the local and regional initiatives. And I realized there is nothing really structured in this sense, but I come to my comment. In my position, where I am director of a unit, of a laboratory, of national laboratories, I have also a data center, a platform. and not only in the digital sector, also in mechanics, in electronics. I face every day, and even more than in the past today, the difficulty in recruiting people with the same skill that they had in the past. The technical services in support of research are going to be squeezed because there are less people, and people are leaving because attracted as well. What we are experiencing is that what exactly you said is not really the spin-off, but the fact that, at least for the digital part, once we have a data center and we develop technologies as we do in our community, with the approval and the label of our authorities, CNRS, university, we transform or we update the data center to a platform, opening up to society, opening up to firms, and we are leveraging local authority funding, because at the end, we want to commit in society, but in the same time, frankly speaking, is one of the approaches, because there are not so many, to try to train and also keep the engineers in different activities. Not that our academic and research activities are not appealing. They remain. They are the best field to train them and then to make them perfect candidates in the labor market. But just because we want to try to find the way, as you said, to engage with the society and find schemes also for different salaries, find schemes for cooperation with hybrid entities that are supported formally by our governments, like the LabCom, national, let's say, public research laboratory and private firms, private industries. I believe that this is based on the individual initiative. Although there are some national schemes, we should consider at European level to support any explorative approach in combining the European Union action and the regional action, but not saying, as it was in H2020, you are welcome to combine the FEDER, the regional funding, but try to support explorative initiative like the LabCom, based on this kind of expertise that we have and the kind of need of combining the regional data centers as well as the challenging scientific perspective of a big of ESFRI research infrastructure. So this is my natural comment based on my personal experience of today.
Well noted. Collaboration by design, not by opportunity. Yeah. Thank you.
So Christoph, please, a last comment.
Mention a comment about within ESA, because we have different we have different areas of ESA. I see much more my colleagues from Earth observation or navigations being able to claim that their data has an economical value and they can create economical spin-off. I think in space science, our data has an inspirational value. And this is clearly what you have seen when we are having this citizen science. I mean, people want to look at the sky, people want to look at the stars, and we've seen that during the pandemic, where we also launched some citizen science project, that there was a huge buy-in. I mean, we had so many citizens actually looking at our data that we had to put more data into the platform because they were classified too fast. And I think, but I mean, that's true, and that's not because the data has a value, an economical value, because it inspires people and we can engage the society. I think this is what Kai was saying. And what I hope is that through that engagement of the new generation of the citizens, then maybe, let's say more the new generation, we will have this pipeline leak where people will be inspired by studying physics, by studying astronomy, by studying particle physics, because they will see an inspirational value.
And on that positive note, oh, well, okay, so we're out of time, but I'm happy to go on for a few minutes if you...
No, very quickly, I think that it's also a problem of attitude, because, you know, if you qualify, not you specifically, Stephen, but in general, as a leaking pipe, the leak is usually the garbage, the thing you don't want back. So does academia want this feedback from real life. And all of the fellowship programs I know of measure their success on how many people go on in academia. So you do a fellowship, and then how successful was the program? By 98% got a permanent job at a university or another research. So there's also that aspect, I think, of what academia is really after with respect to, I don't know what to call them, real life jobs or other stuff. Higher paying jobs. Let's do that. I think it's also that.
Okay, so we have one more question there, and then I think we agree to continue the discussion in the other room where it will be more exciting.
I would like to comment about this comment that about the high salary. It's a problem with when people, technologists or engineers, go to the industry. But I think it's not only a matter of high salaries, it's also a matter of acknowledgement. Because we are living in an academic world, and the evaluation of your career is mainly about how many articles you publish. And an engineer, our time is investing on learning new technologies, apply the technologies, install things, making report, these kind of things. And there is no time for publishing. So we need a new way to evaluate technologies, engineers. There is no ARC program, starting program for technologists or for scientists. I think this is the main problem.
Yeah, so I think you've pointed to an area which we recognize as certainly an issue with engineers and also computing and software specialists. I think we have to convince the management of those people that there should be time to publish. And this is certainly one of the aspects of this whole software discussion that we want to push. So we can't fix it for everybody, but we can at least address it for the software computing aspects of where we work. And that's why in what we're talking about for the future, we want to work with universities, SMEs, and other people to try and address exactly that problem.
This is part of the academic work program of the state.
Yeah. Okay, yeah, it's a final word. Yeah.
The reform of the research assessment is at the heart of the debate in ERA, that it has to move beyond publications. This is, I think, there is a big coalition discussing all these points, as you know very well. And so is, of course, careers, research careers, and equivalence within academia, outside academia, allowing this permeability. The biggest problems being the employment conditions, actually, making sure that researchers are on employment conditions and not just grants, and therefore addressing the precarity to begin with. Thank you.
Thank you. Yeah. So let me thank the panel for their forbearance and interesting comments, and I think this has been a very informative session. So thank you all, and I believe we're now all invited across the hallway.
Panelists, that was not an easy final session, and hats off to I think, Antonio, you had like 15 questions at one point, didn't you, that you had to answer? No, admirable feat. So, indeed, on behalf of the ESCAPE Consortium, you are cordially invited to a networking social cocktail, not in the same place as you were before. I believe Rita already announced this to those of you who were there this morning, but you get to see the dinosaurs, so it's just outside there. And I believe you can also visit the Room of the Dinosaurs too, so that's also an addition. So have fun, rest well tonight, and thank you for those who still stayed online up until the very end. We did have people right till the end there too. Thank you. I know we always leave this to the last minute to say this, but really thank you to the tech team. You know, organising and developing the hybrid part, is extremely tough. So also thanks to all the people behind the scenes. Thanks.